You're running a Bluetooth. Yeah, so you do. Try it.
Hard-coded the event in my calendar, placing correctly.
Yep, here we're so you're all set. Run is you need to change your path or something. Yes.
I figured it out. I made it.
You need
the access point for the character.
Oh yeah. Okay. That's good to hear.
Recently though, I'm noticing I can't.
Okay. I'll keep that in mind.
Other than that,
Okay. She had 2 serial ports as well. I'm not sure why that is, but it was USB 1.
It is running.
Maybe. Yeah. Okay.
It's only using one.
Okay.
And I'm only using. I've tried to use 0. I'll try and 0.
Okay. Yeah, she was running on 1 at work, but I don't think she tried 0.
Yeah.
Okay. As long as it's working. That's the big part.
What's the name of the site that has
Tembo, TMBO.com. Yeah. Yes.
So I guess I confirmed the driver.
Okay.
And then like
Did you? Yeah, you ran the 64. Okay. It's not finding it. Is it unknown? Oh, it's this guy right here. Let's see. Check the property. Maybe remove it and then try to install. It might be. Let's see. It looks kind of weird. Did you open up your Energia? Did you get a serial port?
I mean, it tries to open common, but then
Go to your tools real quick. Okay, serial port. Okay, select that. I might be trying to talk to COM1 website too. Cool. Yeah, you're okay. Yeah, you're fine. So I think your driver's okay.
usually like everything connected, right?
Yeah. Cool. All right, so if you guys are blinking, that's great. You're all up and running. Next step. Is there any push button data? So again, go to File Examples, Basics, and this time we're going to do digital read serial. Cool. So in this example, we're going to do 2 things. We're going to do the push button, and we're going to do the serial monitor. So push button, you'll want to check your pin map again, right? Remember we did that in the very beginning. It was pin 4 and pin push 1. So you can either do 4 or push 1 for your push button. And then that should be it. So go ahead and upload your code. So here you've got your little serial monitor, which is basically a back channel UART to your PC, and you'll be able to get debug data from that. So you click that magnifying glass, you'll get this window that pops up, and you'll see I have my printf statements coming back from the microcontroller, and then you'll be able to use your push button and change that back. So that's kind of the exercise here. We're doing both the hardware input, but also the serial monitor for debug.
What was the next project?
Digital read serial.
You just want to open this.
That is connecting your debugger here to your actual system. So initially you would actually use a jumper, but programming stuff like console, it would be kind of creative. Yep. Okay, great. So now you can do digital read serial. Hey. Oh yeah, no worries. Oh yeah, absolutely. We love that. Yeah. Okay, cool. Sounds good. Yes.
Wait, that's a good question. Sure. What is this doing? So this push button is an H205.
Right, which is, yeah, which is pinned out over there, yeah.
So which one is that?
That doesn't look the older version of the yeah, this new version.
Because this one? I'm not sure if it's push button. This is like such a and then it sets a pin. Look.
Right, that's
And
just
then all
another
it does
statement.
is digital read, and it's reading one.
He actually, did he have you install the SDK? Because that actually has a schematic on it, so you can see.
That's what they gave us.
So there's probably layer SRC. Oh, you're on the mic, taking it off of the GPIO digital read. So probably one of these two pins. And look at just a quick picture of GPIO.
Hi guys, if you are using
Okay, I can just take
the latest version, you need to download the driver from other place. You can Google CC3200 and driver Mac OS. The second one. And you can find there is a link. Yeah, here. Just download this driver, the way work. You can also copy the link there. Download this driver. It's for Mac. For Mac. For Mac with the latest version. And this is for engineer, not for.
Yes, there is. Brian, I want to see you just need to fix the Yosemite. You know the Yosemite Cool. Yes, sir. Okay, yeah, let me check. Okay. Do you need the serial code? So if you have another microphone, that's fine.
Let's go back to that folder. Try this.
For now, I'll come back and. Alright, cool. So next track, you guys are all serial monitored up. got two sensors. You've got a temperature sensor and then also accelerometer, so it's actually pretty cool. So we go to file examples. And then down at the bottom, there should be one called Adafruit TMP006. That's your temperature. So you should be able to just run that one. No, there's one trick I got to show you guys.
Where are they on the left?
We're almost in between the Wi-Fi. Yeah. Well, let me just finish this. All right. Okay, sorry about that. Resolution issues. So yeah, if you go to your examples, you'll see the Adafruit TMP006 library. And that's your TMP006 sensor, which is on your LaunchPad. And what's cool about that one, as opposed to a thermistor or like a traditional direct contact sensor, this is actually an indirect sensor. So all you have to do is actually wave your hand over the temperature monitoring, and you'll see that it's a change in value, which is cool. It's a special TI technology there. But the one thing you'll need to change is you'll see here in the instantiation Adafruit TMP006, you actually want to comment that one out and use the bottom one. So uncomment out that second line, Adafruit TMP006 with the address. And that address is your I2C address. So when you buy an I2C part, whether it's a sensor or display or whatever else, it'll have an address, and that's typically defined in the data sheet. So what's in the hardware, you actually do have to dig into the data sheet usually and like find all these small little things to keep track of. But if you look in the TMP006 data sheet, if you don't have to, because I'm here, you'll see that it's next. So just uncomment that line in the sheet. If you are vegetarian.
I always come out with vegetarians first. Because my sister's a vegetarian and y'all don't get the best pick of what's out there first. So, and I have one vegan in the house. Come on down. So let's start with our vegetarians and our vegans, and if you have like special dietary needs, like cheese one, we got plenty for the meat eaters. Like me. I love it.
41.
Where is the sensor on the screen?
It is this that shiny thing in the top right under that button.
Okay.
You see that?
Yeah,
It's like a
lost.
shiny.
I don't know. Maybe it's just no some chat. Yeah, we need to hang out.
So that's your temperature sensor, and then the accelerometer is under BMA 222,
So you're
and then
not
it's
doing
green
anything
XYZ example. So this one I believe just works automatically, so you just flash this when you get your XYZ data.
Okay.
So I'll upload those so you can see what that looks like.
Alright.
So the BMA 222, that's your library for your accelerometer. So here, I gotta change my baud rate.
Yeah, what's up?
Also, you'll notice when you serial.begin, that's your baud rate for your UART tier, backchannel UART to your computer.
No.
It can run at different baud rates. So typically it's 9600, but some examples they might change, might be 11500, whatever that is.
Yeah.
So here's accelerometer data, right? Get my XYZs here.
Yeah.
For the temperature, we can run that one really quick.
I did. It's a long story. No, I didn't.
Temperature's running at 9600, so just remember to change that.
I'm gonna get it back soon.
And then here's the temperature.
I'm gonna get it back
So if I move my hand closer to it, you'll see the die temperature is pretty constant. That's the actual contact. And object temperature.
Alright, but I might. I just need to figure out how tired I am after this.
See, that's going up. There's my hand.
Yeah. Alright,
Cool.
Thanks for the call.
Any Tenbu, but who's working on Tenbu right now? Has anybody working on Tenbu?
This is awesome.
Well, I'll just go over it really quick, so you guys can get excited for it. So if you worked on the Tenbu stuff, you signed up for an account. And basically how it works is, let me go to the home page here. So you've got all these APIs, right? The API aggregator, as I explained, you've got Amazon, AWS, Basecamp, Bitly, all this kind of cool stuff. If you drill down into one of those, right, you can go into the OAuth, you can go into specific actions that you might take with those APIs, publish a status, get a file, things like that. So basically what you would do, and we'll do Yahoo Weather just as a quick example. That doesn't need an account. You basically will come to this page and you'll see there's a little IoT mode on the top right. You can click that. That'll turn IoT mode on, and then from there you've got a couple options. You've got your Arduino, your Yun, and then your TI LaunchPad. So you can select your TI LaunchPad, and then you've got a 3200. So go ahead and select that as well. And then you got me talking. Yeah, so you select your little connection, whatever that is. Your security type for your router, and then your SSID, which of course is going to be MIT, and then whatever information. If there's no password, just don't put a password. And then that will actually generate code for you. So if you scroll down, you'll notice I'm given this sketch where there's that setup and loop function and all these includes for my Energia stuff. So I literally can just use that copy button, copy that over to my Energia, and run that sketch, which is pretty cool. You'll also need this other header file. This has your Tenbu kind of account data, your API key, your SSID information. You can create a separate tab for that, and how you do that, we're in a fresh sketch. You see this little down arrow, that's their new tab button, also your tab management button. You can do a new tab, you'll say like, Tenbu account, .h, add that, then you copy over this header file. Paste that over here, and then back over here, right, you do accounting of your definitions. So that's how it all kind of connected. Right. So that's how it would work. And then since the people that are working on Tenbu stuff, they're Wi-Fi pros, they'll be able to connect up to the internet and query Yahoo Weather, get that information back in a JSON object, and then they can potentially parse it on a LaunchPad. They could shoot that over to another cloud service to parse it on another server. Who knows what possibilities are endless. But that's basically an example of a use case of Tenbu. Cool. So I think that's
You
pretty
got
much.
half of the meat eaters?
Yes, I think we can get started eating now. You are mostly, for the most part, set up with your hardware. You're able to use your sensors, your and then now we can. Yes.
By the way, if anyone wants to see an audio demo, it's basically audio over the CC3200. It's from one of the other just streaming music. So play some music.
Yeah, play some music over dinner, man. Let's do it.
But you're stuck with my music.
What's
Unless
that?
someone has a
A lock? Yeah.
from the phone.
Mm-hmm.
But I wanted to also set
send a text when you're logged in.
Yeah.
So
you
have
use-
Twilio?
Yeah, you can use Twilio, exactly.
So I could just call them.
Yeah, I would follow that tutorial. You have to sign up for a Twilio account.
I would do like not a motor office.
Yeah, you need a motor driver typically, so you could do like a small DC motor directly from the pin, but it's not recommended because eventually you'll probably burn out the pin. So you'll get a separate little device that you can plug the motor into. Are you trying to hook it up to this robot?
No, this is nothing.
Okay.
I'm trying to look like
Just a lock. Yeah. Cool.
Yeah.
Yep. Yeah. The text message stuff's super easy. Just follow this tutorial.
There we go.
Yes.
Pins can I use of
GWM capable. Yeah. So they should be marked here. That's the purple pins. So I think you only have 3 actually. Those are no connects. If it's light color, it's no connects. What's your file? That's your ice cream. This sensor has this top one doesn't have fluid. The second one has this.
other sensors?
Yeah, there's an accelerometer.
They normally have on site.
Is there a way
We gotta change this is negative. This one's weird. There's a couple differences, yeah. So one is cost. You're typically more affordable, you get more stuff for the same price. Another one is the hardware computer. Use hardware. Another good thing is you
Sometimes like on campus.
and then lastly, if you're building that actual Arduino chips are very hard to get. So you do like this kind of project.
Temperature sensor is here. It's shiny. Oh, black.
Question?
So I'm really sorry. I came in a little bit over and I forgot my.
Oh, no worries. Yeah, you need hardware.
Oh yeah.
Yes. I think so. Yeah, we're ready.
Because the temperature, you connect to sensor or just use the built-in sensor.
Built-in sensor. Yeah.
But I run the code that says no sensor found, so what's wrong?
Yeah. So we had to uncomment one of the lines.
Which
Enable. In the instantiation, it'll say Adafruit There's one that's called hex 41, which is the address.
one? Okay.
You need to uncomment that one and then comment the original instantiation.
Okay.
That should fix it. Yeah.
In about 5 minutes, we'll get going with the next segment of this.
Do I have anyone who didn't put the notes inside? Come on down, hurry, hurry, before the second and third guys are coming. They're coming for thirds. Don't miss out. Or you'll get stuck with the cheese. Jump hard.
Sorry. Yeah, so. Yeah, that you, so. That was what happened. Check your IP address. Should be good.
PDF is good. No problem.
We'll get going in a couple minutes, but just want to introduce Bob Frankston before we wander off too far. I mentioned Bob, earlier, so if you have any questions about spreadsheets or networks or what MIT was like? No, sorry, that's okay. Right. So what was that program that you started? The group? Yeah. How many CIPI members are there? How many CIPI members? What is CIPI? What's it stand for? Student Information Processing Board. CIPI. See that? Times change?
I remember CIPI.
Joe knows what it is. Okay, so what we'll do a quick lineup of what the agenda is going to look like. I'll go through a few slides that are kind of some nuts and bolts of IoT stuff. And recap, really run through some stuff that we had shown last week. I think it'll be useful. The game element of it, I'll describe it to you and then describe the challenge that I'm grappling with right now. We'll defer that until the hackathon start of things. And when the room, we tested it over the weekend and it worked fine in the other room. In this room, I don't know if you can tell from the boards that you have, but it keeps giving me like different IP addresses for the different board and they're in different subnets. So the way and I don't know if anybody here is a network guru and can help me through this, but basically what I have is I have a laptop with a server on it. Has anybody heard of the language Dart, the Dart programming language? Bob's mentioned Dart. So at least one person, good man, Kevin. So anyways, Dart is this language out of Google that I am a enthusiastic user of. Bob and I have debates about which is better, the next version of ECMAScript or TypeScript or Dart. Anyways, Dart is a great programming language. It's new. It's dartlang.org. It's free. It's open source. It's been under development. It's been out in the wild for a couple of years now. Developed by some of the best developers at Google and on planet Earth that we have. It's the same group of developers who worked on the V8 JavaScript engine, for people who are familiar with this stuff. So they know how to make things fast and reliable, okay? Anyways, they came up with this language, Dart. And what it does is it spits out JavaScript to run on the browser side of things, but you can also run it at the console level as server applications. So if you're running it in the browser environment, you're basically pulling in HTML and browser-like libraries. If you're running Dart at the command line, it's got a virtual machine, so it runs on virtually everything. But if you're running at the command line, instead you're calling in file I/O libraries and lower-level networking libraries and things like that. So the application that I have is it's a server. It's basically a web server, and the web server handles lots of different kinds of requests, URL types of requests. And so everybody in the room, the idea was, would download this mini application, and you'd type your very simple edits, type your name in and a couple other commands. And then you'd immediately start pinging, or you're sending out these messages. You push a button, and it would send out a message to the web server. The problem I'm encountering in this room, which I didn't encounter in the room downstairs, was it's assigning multiple somebody's nodding up there, so you know. But so it's and the reason why you can't essentially interact across subnets is for security reasons, right? Please explain it to me, Bob. Explain it to me. It's giving me like these different octets all over the map.
Wi-Fi is a great idea, but it still is a lot of work. The answer is it should just work. So what exactly happens? Give me the IP address.
So the CC3200 is booting up with the 10.189. Let's say 99. Whatever. Okay, and then my laptop is booting up with 10.189. And at the next dot, it's in a completely different. It's not letting me ping across them. It's not letting me.
Then there's something wrong. The answer is it should work.
It should work. Okay. So between now and the hackathon session, Bob is going to guarantee that this is going to work. The game is going to work. Anyway, so I would encourage people, if you haven't, take a look at the Dart language website and download it and do Hello World and you'll be off. Any questions? How many people actually got the CC3200 example application to link or think or do anything? Anybody did not, because we should work with, anybody who did not get the CC3200 actually up to a point of Hello World?
Raise your hand really high.
So we get, Georgios and Anwar and Tony, we've got 3 people who, we'll just make sure everybody gets it. That is the hardest thing about what you're gonna have to deal with tonight, is just getting to this point. Okay, let me just run through a few slides if I could. And then we'll turn it over. Okay.
LS50 is the actual FBI. Garbage. That's
Okay, so feel free to get up, get more food if you feel like you need to. We're definitely, the times are a little bit off, but we're actually kind of getting back on track. So we'll defer the Wi-Fi game till I get either Stuart up and back. He had a good suggestion, which was to set up a separate network, which I brought along here. So this is just what, it's a Wi-Fi access point. So it's the same thing you see on the walls around here, except I can set it up with low security and stuff like that. You're still trying to get connected. But you got a question? So we'll try that a little bit later, but and then we're gonna get quickly to the. People ask, kind of wonder about what's IoT. It's a lot of different things. There are a lot of different attributes, a lot of different components to it. This is kind of my word, mesh of the kinds of things that come up in a little bit more. We talked about why now. We'll come back to this video, which I think let's do it right now because it's kind of a nice. This is actually it's a TI produced video, and I think it's really pretty good.
So the installation is just a power part.
Hi, I'm the internet, and these are your things. I've been talking to these guys for a while. I've always been able to talk to these guys. Don't get me started on that old timer. I'm bored. Don't you want me to talk to this hot little woman? What about him? That's right. I got you, big guy. I can even let you know you're out of butter while you're picking up groceries. I would love to help you at work. Doing your job for you is fun for me. Really. The quicker we get this done, the quicker we can stream Kung Fu! I can keep you from having to climb this ridiculous looking death trap just to check a few settings on a tiny little screen. I can control the temperature. Set the mood lighting. Stream smooth jazz. I'm here for your comfort. I can watch your house for you. Lock your door, close your garage, and turn on your sprinkler system. But there's one problem. I don't speak sprinkler. I tried talking to that big factory machine thing for about 15 minutes before I got home, and all I got was a hum. And I think I fit into the coffee maker. The good thing for you is teaching me to talk to your stuff is easy. Crazy easy. And with the simple link CC3100 and 3200, you don't need to worry about that Wi-Fi stuff. Texas Instruments has that. You know how to use an app, and you're good to go. And it's secure, built in. You don't want your neighbors unlocking your door or turning on your sprinkler system, do you? They were using my wireless internet for 6 months before he changed the password. Still have nightmares. Worried about power? Don't. This little beauty runs off 2 AA batteries for over a year. So what do you say? Help me out. With all the time you save, you can finally get caught up on email. But we both know we'll just stream more. Check out the Simple Link Wi-Fi family of devices and let me talk to your thing. What will you connect?
So that's kind of a cool, I thought Texas Instruments produced that. It gives you a sense of what, at least in home automation environment, it might consider. Here's my definition of what IoT is. It's a little bit, it's simple, and it's hardware, software, networks, apps. And actually, early question about people. I actually view the people component as significant, at least the way I view IoT. There's a separate sort of realm of machine to machine, sort of products and services and companies that is really focused on the industrial machines, talking to machines, and essentially, kind of machine learning and everything happening without the interaction of a person, right? My view of what that makes this really interesting is that it makes lots of additional technologies more accessible to people. Here's kind of my pictography of what I think the architecture of IoT really involves, and these are the kinds of things we talked about last week. So, you really have devices and sensors on your CC3200s. You've got accelerometers, you've got a thermo, temperature monitor. You've got these powerful little devices that connect wirelessly via some, protocol or some radio frequency to bigger, what I sort of consider to be like gateways or hub servers. This happens to be BeagleBone Black, which is another product that Texas Instruments is behind, and it's more capable of processing the loose data bits that come from here into some semblance of meaningful data, but still within the confines of your own private, secure, potentially network, right? And then you jump out to the cloud, whether it's the Tempo stuff or other third parties, where you're suddenly, transferring your data from maybe your own backyard lawn watering system to, some repository up on the web that archives it and makes good sense of it. But I'm not sure if it was Bob or someone else who, pointed out the irony of sort of sending the data from your switches and your home environment to someplace far away to control it when you don't know what the operational security of that place is or what the reliability of the network link is to that location. So in my view, at least, the more that you can do locally within your own confines, and that you then selectively decide when and where and how to securely pass it off to some other device on the other side of the cloud, whether it's a laptop or a smartphone or something like that. So one of the other applications that we showed the first IAP was essentially controlling from a cell phone the sensors that were on a BeagleBone, or for that matter, on a CC3200, right? And the manner in which you carry that data from device to device, eventually it's going to go over a protocol, whether it's CoAP or HTTP or some other protocol. That's, I see some people brought, it looks like you guys got something. You want to just hold up whatever that is and describe briefly what it is? Is this like your little robot thing?
Oh, this one?
Yeah.
Oh, just before this workshop, I attended another one.
Uh-huh.
So this is actually using Bluetooth, so the protocol using your phone to control the automobiles.
So you end up with lots of devices like this with wires and stuff hanging out of it. We have, by the way, lots of connecting wires and all sorts of things up here that we can pull out for a little bit later on. Here's sort of my toolkit of my bin of devices that. So this is the thing that sits in my garage, and it's got a passive infrared motion sensor on it. And when the door opens or somebody walks through, it's actually connected to a 3200, and it wirelessly talks to something in the house that lets you know if there's something going on. This was something that we set up just for MIT last week, and it had a little buzzer on it, This here is a light sensor. These sensors cost maybe $1 or $2, or the passive infrared are more like the $7 range. And then buttons, and you've got a couple of buttons on the board. But so the things that you have mostly concentrated on tonight, and for reasons of time, efficiency, and lots of other things, it's great that this board has buttons on board and it's got the accelerometer on board, so it's all self-contained. But the next step beyond that actually is to start to use the pins on the board to connect external sensors and external controls so that you can get a little bit more creative. These things actually, from Home Depot, electrical boxes for $1.50 or 63 cents or whatever it might cost, are about the cheapest way to reliably transfer your home projects around as well. So, eventually, and here's just another one, it tends to get to be a mesh of wires. And I think the next step in this, within the reach of everyone in this room, if you get to a point where you've got a device, whether it's monitoring your backyard garden or, where your bicycle is located or whatever it may be, and you believe that, well, this thing either has commercial value or you'd like to scale it to something that is essentially manufacturable, that should be within the reach of everyone in this room. It might take partnering with somebody who knows how to do a board layout. It might take talking to Kathy to find out who at TI would help you through that process. But the other thing on these boards is that they're all open design boards, right? So TI makes them a bit, there's no real hidden secrets in how the board is laid out or, magic behind it. It's really quite... This I just wanted to kind of get out there. I don't know if people have heard about this, Google's request for proposal on the open web of things. So here's Google. This is just within the past month or so they posted it. And the deadline, if you look closely, is like it's imminent. It's like a week or two from now, right? So if anybody's interested in getting in on an RFP to sort of, explore this, Google is, in my view, the only reason they're putting this out there is because they don't really know the way forward. And they need lots of input from people who are out there doing it. Lots is happening, in real time, right? So one of the folks who is on is Vince Cerf and on this review board, right? Another person on the review board for these RFPs is the CTO of Nest, the company that Google acquired that has the smoke detectors and stuff like that, right? And Nest has initiated its own lightweight protocol called Thread. Don't know if you've heard of it. Don't know if it's going to come up in the co-op talk or not. But it's their way of communicating with these devices in their own network. So they have a Thread Alliance that is kind of getting ramped up this stuff. These are things that are probably not super interesting. They're a little bit dated at this point too, but these are two case studies that I worked on with several other people down the river, and looking at how protocols on a large scale, in particular this was like Wi-Fi stuff and DSL stuff, get standardized. And in one case study, the other case study we actually looked at, there was a WAPI was the name of the protocol that sort of the people in China were trying to advocate, and why it did succeed or didn't succeed was kind of interesting. I think the big thing is IoT is happening now, right? So you can go right out to the web. This just popped up on January 27th when the FCC released the report on the Internet of Things, right? And of course, the headline that people come up with is the Internet of Things is going to be a legal nightmare. Not that it's going to be, people who work on it or get involved in it are going to head down the treacherous path that the Bitcoin entrepreneurs have taken on. It's not that kind of legal nightmare, but it's like, who owns the data? Who owns the security of the data? What happens when the data kind of gets out there into the wild? Lots of it, and if the FTC is kind of promulgating their staff view of this right now, then it's very timely. Okay, so transitioning to co-op. About a week or two ago, actually it was Bob who pointed out this co-op stuff. He wondered, where's it going to go? And we looked into it a little bit. There are two implementations of co-op out there in the wild that we found. One is in the language Go. Have you heard the language Go? Right, so it's another Google sort of systems oriented. This guy Dustin, who he did an implementation of it. I've been in contact with him on a couple of occasions. There's a client server. He did it really as part of a hackathon in a few hours. So the point in saying that, he worked from the spec. The point is not that it's interoperable and it's robust and deployable, but it was a creative first whack at it. And this guy, Toby, had done micro co-op, which he kind of targeted at the Arduino platform. How many people have worked with Arduinos? Fair number actually in this group, so the target for that co-op implementation was for the Arduino, and then the fearless trio of TAs at the back over the past several days with some help from Robert and TI, they actually ported this stuff and got it working on the CC3200. This stuff meaning the small micro implementation of the co-op, and we'll talk more about that for anybody who wants to hang around afterwards after the hackathon. But Bosky was very kind to take time out to come here, and what we'll do is we'll pull up, see if I can pull up the nice video that you had there. Is that, yeah? See if I can find it. Slides, and type, sorry.
Maybe so slow.
Slide.
While they're changing slides, can I just ask if you did not email Brian before the class, so that he has your contact information and you can send me an email with the slides and stuff, will you please come and check in with me? Just sometime before you leave.
So this is a beautiful video that Bosky put together, and there's a way, because it's a little hard, it will be hard to project the elegance of it to the audience because we don't have an overhead projector. It's only a minute and there's no audio, but Bosky, you can take it away from here. Thanks.
Hi, I'm Bosky from the Kinoma team. This demonstration is actually I took two devices these are called Kinoma Create, our devices. And these has a Linux full stack of the small computer with the touch screen and the Wi-Fi embedded. So I implemented the co-op on top of the system. So this device is synchronized using the co-op, which is changing the slider. The left one is client and the other one is server, which have the LED connected. Then changing the slider from the client to the server, and then color information is sent to the server using the co-op. So this is very simple example. So obviously we can do this using the HTTP, but so there's a many benefit of the co-op. So let's talk about that. Brian who? Oh, nice. Okay. So, how many people knows about co-op before today? Nobody? Some. Okay. So I will introduce about the co-op from the very basic level. Then, so demo is already done, and talk about the protocol stacks. Okay, let's start. So what is co-op? Co-op is it stands for the constraint application protocol. So it means the very limited resources, embedded, for example, embedded devices, such kind of the IoT M2M situations. And it already defined in RFC, so we can start using this very safely. And I'm a pure software engineer. I don't know much about hardware, but I do software law. So from my point of view, co-op is just a lightweight, fast HTTP. So what does it mean? So co-op is very lightweight. Lightweight means compared to HTTP, it's very lightweight. So message is very binary format, And binary is very easy to pass and build back to the protocol level because computer likes, program likes binary, but we human loves to read text. So that's why HTTP chose the text representation, but co-op is for the constraint situation. So co-op is very binary. And have you ever read the HTTP browser source code or HTTP server source code? It's very, very different. So only pass of the header, those codes can be shared, but almost everything is very different. Co-op is very symmetrical. So client and server shares many basic level of source code. So it's very easy to build the client and server, both inside the very embedded, small, limited resources. And so our FC document is just 112 pages. It sounds very huge, but for this kind of protocol, it's a very very small. If you have to build the HTTP server, you have to read more than maybe 1,000 pages of document. So 112 is good number. So co-op is fast. Fast because it is implemented on top of UDP. Have you ever heard about TCP/IP? Of course, yes. But there's another variation of the network protocol called UDP. Do you know about, the people knows about the UDP? It is very known as it's stateless, no connection, and overhead is very small. And the co-op can be can be faster by choosing the, if there's no reliability is required, co-op can be, that reliability can be common, and it can be more fast. So the most important part is a co-op is almost HTTP. So these days, people who program using the HTTP as the talking to the server side. So people already talking about using that like jQueries.ajax. Such kind of the interface is HTTP. And so people already knows about the request and response style model, and also REST. REST is the resource-oriented programming style. Also, URL is has its own URL style, very similar to HTTP. So, and also content type is available. So it's very HTTP style programming language. But HTTP is, I love HTTP so much, but it's great. But there's some bad things there. So like HTTP is very reliable, but based on the TCP. And I'm talking about this later, but and HTTP headers are very huge. So no, I mean it's just a text header, so hard to pass. Without regular compression and regular expression, it's very hard to write a parser for these days HTTP headers. And almost every headers are not required by the JSON, like API style programming. So passing and throwing them is a waste of time and the resources. And so a header is very huge. So Google's report says it's almost 700 or 800 headers for each request. So one server and they send back the response. And header is almost 700. It's huge. Actually, if the response is just okay for 2 byte, they have the 700 headers, so it's very a waste of time. So apparently, it is not the best choice for IoT. So co-op was developed. Co-op is not HTTP for these reasons. So co-op chose UDP. I'll talk about UDP's good point later. So co-op is has no overhead on its header. Header is very little, very and it's binary formatting, so it's easy to parse, and that's very small. Also, content type is HTTP can define your own content type, like x.application/basket or something like that. But co-op standard types of the content type can be used, but only that. So the headers also cannot be extensible by users. Then the last part is very important. The co-op is based on the UDP, so it is the most important limitation is the packet size dependent. So TCP doesn't have the concept of packet. I mean, it's a kind of string, so I can send a gigabyte of the file. But UDP is very data-ground protocol, so it must be fit inside in the packet size limitation. And on Linux, it is basically usually it's a kind of 1K is okay, but just 1K. So why the co-op chose UDP? Because it's fast and simple. Connectionless means that the TCP when start connection, when start communicating, TCP requires to connect to the server, then start sending something, then close the connection. UDP is there's no connection, so I can send the information to any server in the internet, then forget about that. So it's very simple. And so it's already, so if you don't know about UDP, but you already use that because it is for the video streaming or DNS. Nobody depending on the DNS. Everybody uses DNS, DHCP, or RAID. And also, the UDP has the strong feature of the one-to-N communication, which is the so multiple. I can send the one request to reach to the many clients. So it's very good, strong feature. And as I said before, small overhead of packet. So every packet, TCP has packet itself, but it's very hidden. But every packet has more than 20 byte information into the one packet. So it's very huge overhead for the TCP. But UDP only has the 8 byte overhead. So still 8 byte of packets, but 8 byte of the overhead, but much smaller than TCP. This part is the most important part. Yeah.
How co-op is compared against the HTTP over UDP?
Okay.
Seen some implementation of HTTP, like their HTTP.
Is there HTTP over UDP?
Yeah.
Oh, I'm sorry, I didn't know about that. So maybe I'm talking about the reliability, and maybe that protocol must implement this kind of the feature. Of course, TCP do a lot. TCP do many data collection or the data ordering program fixing. Such kind of a very important part. Without such kind of the reliability, HTTP doesn't work. So sorry, I don't know much about that, but maybe I'll cover that later. So UDP is unreliable. Unreliable means packet may be delivered to the destination more than once, or not delivered at all. This means if I am a client and I send something to the server, I have no idea packet reached to the destination. So this sounds very unreliable. And sender does not know if when packet is delivered. Okay, so packet can be delivered very late, delayed, and so with UDP, usually programmer have to implement such kind of reliability in the application level or protocol stack. So as I said, TCP is very reliable. Every protocol, many protocol uses TCP because it's very easy to program. The important part is the second one. If I send A and B information on the order, destination can will get A first, then B. This is the protocol. TCP does assure that. So it's programmer doesn't care about the order of the packet. And the last part, congestion control. This means if there's an error, I will send that again and again and again. So sooner or later, the packet, the error packet, it filled up the entire the bandwidth. So some level of the congestion control is required. So, for example, retry must be happen several times, but then gave up for such kind of congestion control. So, co-op has such kind of reliability feature on the protocol level. The programmer who uses co-op doesn't care about such kind of little bit care about such kind of things, but many things are already cared by the protocol. So library, maybe if you use the library for co-op, the library will do that. And so the reliability which co-op has is the duplication detection. So as I said, packet will be sent twice or more. So I sent one request, but I got 2 or 3. Sometimes I got 2 response from the server. So each request had each message had the message ID. So I can detect that by application level or protocol level. And acknowledgement response is later. This means that when I send something, server send acknowledgement. So that people, the application can know my information delivered correctly. I'll talk about token later, so skip this. And retransmission of message. So if the program doesn't get the acknowledgement, it automatically retransmit to the server, so several times. So until it hit to the limitation of the retransmission, it automatically sent to the server. So application can forget about this kind of retransmission for a while. And this is the most important part, maybe. This reliability is optional. So if you don't care about the reliability, because I have a sensor here, and server requires the sensor's information, but that information is always sent. So server doesn't care if he loses some packets, one or couple of packets, but because new data will be counted for the couple of seconds. So if you don't care about such reliability, just forget about it. So HTTP is infrastructure. This means, as I said before, we use HTTP for the everyday programming. Yeah.
Sorry, this is a less theoretical question. If I wanted to change the options on the version of the collab running on this thing, how would I do that?
I'm sorry.
How would I change the options, like you said?
Every request has the, you can choose this request is reliable or not. So I'll talk that later. So let's dive into the demo. The video I showed you is this kind of style. So I use only 2 devices, but wire can be any number of devices. And if I change on the server side, change the color, each line get the information update and change its color. And even from the terminal, I can send the call up request to the server, and that spread to every client. So it's very easy to test. I mean, the request is standardized using the URL. Okay, so this is the keynote grid. So for the code, I can show you every code. This is the basic style of our Node.js environment. So just like creating a client, then adding the callback, then finally send the request like this. It's very simple. This is defined by me, and there's no standard API definition. So the people who made the library will choose the style. Maybe I will change this style, like using the promise. So request will return the promise, and I can set the then. Anyway, so this is looking important. Okay, so the index. These are message format. It's a binary. The top part is the bits, so 30 bits, 32 bits in one level. This is a fixed data. So every message of the call has 4 bytes. It's minimum. And it includes the version number and what type of message and the token length. I'll talk about token later, and also call message ID. So token. Every message can have the token. Token can be any 0 to 8 byte binary data, and if I send some request to the server will send back a response with the same token. So that I can distinguish the request and separate and distinguish the response from which request to response. This must be required because UDP is very reliable. The request I send first and second, and the response can be in that order or not. So programmer has to take care of that. So token is good usage for that kind of thing. And even other use case is like a sequence number. Every time I send a request, I include the integer inside the token, and that includes every request. And that's so that I can get the response order in the as same as the response request. Options. A little bit. The name says option, but it is HTTP, like a HTTP headers. Options can be added for the kind and the value set, and as many options as you want to one message. And the option can be used for the content format and anything that added to the information to the request. Even the URI is encoded inside these options, and it is also the very binary specific format. So if the value is integer or something, it can be, there's no representation of text, but the binary itself is embedded inside the option. So it's very space efficient. So payload is the content, just the body of the HTTP. So it can be anything. But as I said, it's limited to the one packet, so you can send huge information. But the content type is limited to text, JSON, XML, EX, and the kind of XML, and the binary. So for JSON, it's very one case. A huge space, so it's okay. And the message code. This is the as I said, the RESTful request can be sent. So get this one has the same kind of HTTP response code, like a 200 or something. So it is almost like a HTTP response code with the request method definition. As the same with HTTP, 200 is success, 400 is client error, and 500 is server error. Messenger is required field for every message, but it is used inside the protocol level. It manages the retransmission or such kind of things. So programmer don't have to take care of message ID. It is automatically assigned by the library. Then message types. 2 bits of information in the text at the very beginning of the key is the type, and that type is a message type. And the question of the how can I choose is you can specify the conformable or non-conformable to each event. So conformable is the very reliable, and non-conformable is without reliability. I talk about the list later. So at first, conformable. So conformable requested the left one. Client will send the message request, then server respond with acknowledgement. So with the data, like the hello is the data, or server can send a separate response. So what does this means? Request arrive to the server, and server is not ready to send back the response, but it has to send something back to the client because client is waiting for its acknowledgement. So acknowledgement, empty acknowledgement can be sent. Then later, the server can send the response. This is called separate response, and the left line is called piggyback response. This is non-conformable. It's very simple. One sends something, server sends something. It can be both non-conformable. Usually, if server got the non-conformable request, they will send the non-conformable response. But the server can send the conformable response, whichever the server wants. So API is used for this purpose. Sender, the client and server can be sender. Client send the request, as in that context, client is sender, but the right side, server send the response, and this time server is the sender. So sender sends something, and the receiver will has to respond with acknowledgement. So retransmission, this is a very important part of the reliability of the co-op. So as this diagram, the server sends some client sends a request, but the server, for some reason, it doesn't reach to the server. Then timeout happens. Client didn't get acknowledgement until the timeout happens, so it's sent again with the same message ID. Then server will, if server got that message, as usual, server will respond with acknowledgement with data. Sometimes a little bit different. So this time, server actually didn't get the request, but sometimes server get the request and respond as usual. But that acknowledgement does not reach to the client because of something error. So client has no acknowledgement, so timeout happens. Then it's sent back. The retransmission happens again. So client has no distinguish with these two cases. So server logic may have the same request twice. See, the request, both requests are completely identical. Server got that twice. So server has to take care about that. So usually it cached for a while until it expired as a result.
What's the point of caching it if it's not going to retry?
I'm sorry.
What's the point of caching it if it's not going to try third time?
So if to make the response, server requires a huge calculation and or time dependent. So it should be cached and identical to the same. Prepare for to send an identical response to the client. So cache is the best part, usually best.
So in the cache it will say that it's
The
send a message back, we didn't get it.
Yeah. And sometimes this can be hard. Server send acknowledgement, but before client gets the acknowledgement, but the timeout happens because some delay of the delivery. This happens often actually, and again, there's no the situation for server is same, and this time client just ignore the second acknowledgement, and which means it's not. Server does the same thing, acknowledgement twice with the data, but this time client will handle this response because client doesn't. There's no clue which one is which. So first one will win. First one will win. Okay. So there's 4 types of the message types. The last one is reset. Reset is just the exception. Sometimes client will die when this is some example of the separate response. Server send the empty acknowledgement, and later server will send the real response. But before server send the response, somehow client died. So client lose every information because client has to remember about the request, but it was gone. So when server sends some response, client doesn't care, that doesn't have information about the response. So client send back a reset. So it is very exceptional case, and usually protocol automatically takes care of this. So programmer doesn't care about that. But maybe callback will be called to the application. Some unknown response was arrived. So do you take care of that? Such kind of the callback can be set. This is the design of the library. But one thing it is very useful for the reset usage is the ping. Ping is if I send some unknown message to the server, the other endpoint. Yeah.
Oh, sorry. Did you say that reset causes the server to like reestablish that the guy is still alive, or what does it do exactly? It just tells the server that the guy died.
Reset will be sent from the server because from the client, because client doesn't know about the response. Client,
But it still receives the hello package.
yeah, client will receive this hello message, but the client doesn't know. This client sent the request because it was flashed. So there's no information about the request. So
the server has to send it again, or will the request be sent?
server usually if you got the reset message, server will erase this response from his cache. Reset is to manage to stop the retransmission of the message. And the ping is with this mechanism. Every endpoint has to both client or server has to send a reset when it got the unknown request message. So this can be used for the ping. Both message is very empty, so it's just a 4 bytes. So it's minimum size of the mechanism to minimum size to get the aliveness of the other part of the protocol. This is the co-op style URL. Scheme is the co-op. There's no surprise. So this is the basic information about the co-op protocol. Observe is so I'm talking about a little bit about the extension. Observe is very important extension for the co-op, which is extended to this feature has no counterpart of HTTP. So observe is like a subscribe on the publish style information delivery. Once client sends the registration request to the server keeps sending the information to the client. So this is very useful for actually my demo example uses this observe feature. So once client launcher, we send the registration request to the server, and the server keeps the client's references. And once file was changed, it's sent back to the notification to the clients. So it's very easy. And this is called extension, but many libraries already implement this one. So it's very and maybe you can use that. Another extension is the block-wise transfer. As I said, so packet size is very limited. It's sometimes very low. Sometimes in some situation it's less than 100 bytes. So block-wise transfer is the extension that co-op can send a huge response by separating to the small blocks, and the client will regenerate the original response from such kind of block. This is also well supported by the many libraries. useful feature of the co-op is co-op server should be support this feature, resource discovery. Let me see the storage path /well/core. Every co-op server should support handle this URI and return the information about the resources the server has. Like for this example, it is iot.eclipse.org, and they have the test server for the co-op. So you can start trying with the IoT Eclipse.org. And they have a bunch of resources. There's a small description about the resources. Resource is the one at the endpoint. And this tool is very useful. Just search the add-on for the firewalls. It's called Kappa. And it's a interface for the co-op test. So if you want to try that, just Google the Kappa. So I'm talking about the error or security. So from the beginning, I said HTTP is very reliable. Errors are handled TCP layer, so programmer don't care about the errors. If error happens, usually network is down, so you can get it. The co-op componable request, it's almost same with the HTTP. So if error happens, you can forget about that request and show display error for the user. But you have a choice of non-conformable. So this time error happens so often, which means the programmer has no idea error was happened or not. So just simply errors ignored. So you have to add some mechanism to take care of the network errors. It's up to you, but usually you just forget about the error is not a good idea. So sometimes you have to ping to the other side, and but less frequently. And the security. So HTTP uses TLS, SSL, TLS, and as same with the HTTP, co-op uses datagram TLS. I don't until I implement the co-op, I didn't know about this datagram TLS, but it is already supported by the major libraries like OpenSSL, NSS. So you can use the security. And this is the important thing. Security is usually for the encryption to protect the information inside the connection. But co-op uses that for the authentication. Actually, HTTP can use the certificates for the authentication, but it is uncommon. Usually, people don't do that. But for co-op, for example, public key and shell key, the private key, if people hook up the public key, can be connected to the server. So such kind of purpose, security is used for the authentication. And that's it. So this is summary. The good is very fast like the HTTP. And also there's a bad thing, small data size, unreliable, and very new protocol, so less information. So, and application has to take care of the errors more than HTTP. This is your responsibility. And you can find many implementations, but those are not, some of them are not well tested. So the Ruby has the co-op extension. So just it has on the gem install code, it installed the co-op library with the command line tool. So it's very useful. And also Java has the implementation. And that's it.
Questions?
Questions?
Yeah.
So, this is one protocol, right? So in the scene of the whole IoT space, where does it rank? Are there more that are getting more popular, or this is the thing, or where does it stack up?
Depends on the, so, you know, we know about the 6 low bound, as mentioned about the here, right? 6 low bound is the low power IP everywhere kind of stuff. Is this popular? I don't know much about this, but if this one will be popular, maybe co-op is best choice for that. So right now, everything is TCP/IP. So we have a very fast infrastructure. So this is good, but usually HTTP is good. There's no differences. But for some situations, I tried this kind of the style, server client style communication using the accelerometer. So I put the accelerometer on here, and the client gets the information. Sometimes HTTP is too slow for the 60 frame refreshment. So for such kind of the critical situation, co-op is a good choice.
Can you talk about how co-op relates to public subscribe and to WebSockets?
I don't want to talk about this. Well, before I implement co-op, I implemented the WebSocket plan startup. And WebSocket is simply just a socket. So it's very good because the client and server side both have the same symmetrically sockets. So server can send information to the client anytime. And also the client can send back, not the request and the response time. So it's very good, but not good for the REST style communication because it's so free. So the people who really uses WebSocket is define some protocol on top of WebSocket. That is called, I forgot the name, but the mix of the REST style request sending and also the publish subscribe style of the event-driven protocol. So that's the strength of the WebSocket. WebSocket can be anything, but real application requires other protocol on top of WebSocket. So co-op is very REST style communication. Maybe other protocol MQTT. This is also known as the IOP style protocol. This can be used for the publish subscribe model, but it doesn't have the REST style the API. So maybe depend on the project. But co-op has the observe, so observe can be used as the publish subscribe model. So it's good.
After this, the TA folks who put together the co-op for launch the CC3200, they'll talk a bit about it and what that experience was like. And one of the neat things about this is you really can dig into the protocol, compare co-op to HTTP, for instance, on the hardware that you have, and really understand where the differences are and why the lightweight sort of version of co-op really makes a big difference.
So micro co-op implementation, that was every reliability things was committed. So it just sent non-conformable request. So that's why it's very likely.
Sure. Yeah.
I'm sorry.
How do you provide communication? You just use it as a script to written, or do you provide
Actually, it's a no.
Could you repeat the question? Sorry.
About the security. So the question is how to specify the.
How do you provide?
Client has to have the public key to the EPS. Then it start talking to the secure port. And it is responsible. The responsibility is on the application side. So the application has to have the interface of the server. And server side, maybe when launch server specifies the key. It's the same as the HTTP. But there's no open standard certificate list like every browser has a kind of list. But for that, because it is for the specific uses for the focus itself. So not the general.
Was there a question at the back?
Oh, so is the application supposed to specify the message type for like the secure, or sorry,
Reliable.
reliable or unreliable?
Yeah.
And like, can we look at the code to see?
Oh, sure. Please take a look on after that.
Question in the front.
The server is linked to, can you run the server on one of these embedded devices, or are you supposed to run that on more?
Well, I think it's possible to implement embedded from a slow co-op server, but the resources are limited, so maybe some sort of limitation will be like a microphone throughout the so, but it is possible. Many codes are shared with the client and so on.
He'll be around later, so we can do more questions and stuff like that. A round of applause, please. Thank you. Okay, Kathy and the TI folks, you're going to have some words about what they're up to and all that.
7 minutes. How do I do?
This is my first English presentation.
How's that?
So this is the start.
Okay. So again, I'm Kathy Wicks.
He's Rihanna Doggett, University of Virginia.
So my partner in crime. And Richard, if you're a student, you could be at MIT, could be anywhere else. Really high. Congratulations. That's awesome. Any faculty in the room? Any other guests? I'm starting my own company. Excellent. Welcome. Okay, so I'm going to be really quick. My role at TI is to promote the use of TI devices at universities. We support all kinds of university support since the beginning of time. The 1930s, when TI began, some of our very roots were associated with working with universities in geosciences. And anybody have a TI calculator when they went through high school? Yeah, still have it? It's like a friend, right? It's the only one who knows the answers to the exam with you. And mine was like my best friend, right? Anybody see E.T. Phone Home movie? Or Toy Story? Right, recognize the big guy in the middle there, Speak and Spell? Really cool use of DSP technology. More than just a toy, the Speak and Spell gave the opportunity to productize in a huge volume a very difficult mathematic consequence of signal processing. Anybody know
This is the.
where the birthplace of DSP is?
Which ended
In the chip, yes.
this design.
MIT, yes. And who's still on faculty here?
No clue.
Okay, go back and think about your signals and systems books, EEs in the room. Alan Oppenheim is still on faculty here, very good friend of TI, still teaching a sophomore class in signals and systems, wrote the original textbook in like 1973, history was born, and the DSP in the 80s is the engine beneath everything that's in your pocket today, right? All of your cell phones and your digital still cameras, and now it's all combined into a PDA. So next thing, what I'm interested in is what you're going to create. And IoT is going to be that big wave for us. We're going to create things that nobody's ever thought of before. In universities, I work with faculty in over 4,000 universities worldwide. I don't personally go to all 4,000, but I try really hard to get to know what's going on in each one. My responsibilities are primarily in North America, but I'm going to go to China next month, so we'll see what's going on there. And we work with students in a variety of different departments. It doesn't necessarily have to be EE. Wherever our chips and boards are being used, you can see everything from like heads-up displays and software to analog senior design projects. LaunchPad is one of my favorites because it's super low cost, and if you put it on a rocket and blow it up, that's okay. We can get another one out, do it again. One of the things that we do is specifically tailor some of our benefits to educators. So if you can do me a favor, you're like, the pizza was really high quality tonight. I think I'd like to do a favor for Kathy. I will send her an email with a faculty that you would like for me to work with. Today at MIT, we worked with a couple of instructors. Jim Hong over in the ECS uses some of our devices in the FPGA labs there where they add some analog chips to it. Dr. Lee uses a couple of our chips in this motor lab, but there may be some other places. There's lots of people that I haven't met yet. And as you can see, we work with educators directly, we give them teaching materials and access to equipment and some help to get up and running on the latest chips. Okay, so but students directly, and one of them is the flyer that we passed out. For students, here at MIT, we're able to extend discounts for you. I do a lot of donations for projects. You send me an email, tell me about what you're trying to do. You've seen a TI EDM on the TI eStore. You're kind of interested to integrate it into your master's thesis, your undergraduate project. Any members of the IEEE Student Club? We have a workshop with the IEEE Student Club. Join the society. We have done a workshop at IEEE on this campus show. We do a lot of that on other campuses. Other student organizations that you're a member of would be really appreciative if you would connect us in. The design competition that's on your flyer. I think that's my next slide to tell you about. Yeah. So the board that you have access to right now counts as a chip in this competition. And it would be really super cool if we had some teams registering for the competition. You just have to use one processor, which you've got one right there on that board, and 2 additional TI analog chips when you're building your next generation flood control things so your sprinklers don't go off via IoT. I'm not sure what you've got in mind. But anyways, you guys are going to build something. Come and talk to me during the rest of the evening if you'd like to talk specifically about a particular project. I'd like to hear about it. We have some giveaways that we're doing tonight. The first one goes to Brian because I'd like to thank him very much for this. For Brian, we have the very popular instructor's polo.
Very large too.
Very nice. It might be too large. It might be too large. And then, of course, do I have my 3 lab TAs, George?
Yeah.
Anwar and Tony, come on down. And for Brian and the guys, we got them very nice. Woo. Here we be a t-shirt, lots of fun.
Guys, next time gals, I think there's a good distribution of women in the
So,
audience,
if you guys have time to pick your size, then the rest of them, we'll do a drawing, and I'll pass out some numbers. We'll do a drawing. I also have a nice micro engineers book that you may be interested in. This is a friend of ours, Simon Monk. I don't even know if he uses TI devices in this book. I just know it's a really good book. He's an awesome author. He also writes other books on Arduino. He has one on people board. And so, getting that away tonight. I'd like to hand over the stage to my friend Adriana, who's going to tell you about working at TI. But I'm going to put in an advertisement first, Adriana, and ask you to come talk with her because I worked at TI a long time. And when I first joined TI, my friends, TI was not really a semiconductor company back then. It was an equipment company that happened to make semiconductors. I was in the semiconductor division. TI has changed a significant amount since then. And that's one of the reasons why I stayed. I never got bored. I have done amazing things at TI. You can come and talk to me about the brain. I have met Stevie Wonder's eye doctor and worked with him on a prototype for retinal prosthesis. How cool is that, right? I have been on a secret trip to a major manufacturer of children's toys. I was not even allowed to tell my family which country I was going to because it might be obvious to people when you go to Billund that you're going to go and work with the Lego people. I have done some phenomenal things at my time at TI. So I really recommend you talk to Adriana.
So let me just interject. I didn't quite realize it was going to be a recruiting session as well, but I'm happy it is for your benefit. Flip side of it is I get a commission. Anybody who signs on, so you know. But no, anyways, TI. I mean, we should all recognize this, and a round of applause for the Texas Instruments Park because we couldn't have it. So you know, they really truly are really just good people. Everyone that we have dealt with at Texas Instruments, it's been a pleasure. We couldn't have done this, any of it, the previous week without Joe or you know, any of the folks on the other end of the line here. So it probably is a really cool place to work. So by all means, they'd be lucky to have you as well.
I'll say real quick, as an MIT alum and a TI employee, I had no idea that the College building in Cambridge was donated by Cecil Green, who was the founders of TI.
Yeah.
So I had no idea, especially running up and down it. That concluded.
I have a lot of history, a lot of history, and a lot of connections with MIT. Well, guys, again, I'm Adriana, and I just, I'll keep it simple, I'll keep it quick. If you're not familiar with Texas Instruments, I urge you to go do your recon and get on our website and learn about our opportunities. There's a couple of different sites that will lead you to the same place, which is where I primarily work, which is on the recruiting side. Careers at ti.com or ti.com/students. I particularly like ti.com/students a bit more simply because the content on that page is extremely rich with projects, with videos, and a little bit of everything that you might actually help you decide whether or not TI might be the place for you to consider for an internship or a placement opportunity. Okay, so huge company. We're in about every single product you possibly think of. It's an electronics product. Again, get yourself familiarized with that huge company as well. We operate pretty much everywhere. Our actual profit sharing was just announced last week, and that's pretty phenomenal. So the company is doing really, really well. We're actually getting a 15-point-something% bonus because we did phenomenal. Now that's actually really, really great because that's a jump. I think it was like 8-point-something% just last year. So the company is just a driving force. It is an extremely innovative place. I'm actually one of the babies. I've been with TI for about 4 years now, and most of my colleagues have been there for many, many, many years. So it goes to just letting people know it's a place where you can actually really, really grow your career because there are so many different aspects of what people do at TI that you can move around so easily and never get bored. There's always something going on. So a little tidbit on that for you guys there. We are a global company. Our positions are based out of Dallas, Texas. The majority of our positions are based out of Dallas, Texas because that is headquarters, but we are looking for folks all over the place, okay? Dallas is our headquarters, biggest site for recruiting. Santa Clara is now a really big force for us as well, ever since the acquisition we had out there. Then we have an office in Tucson that actually recruits a lot of students to come out and do internships out there as well. We have an office here locally in Manchester. It's one of our power analog offices, and those folks are pretty tied into the folks here at MIT as well. So that gives you a sense of where we are and who we are. On the recruiting side, though, if you go out to the site, like I said, peruzati.com or students, this little slider slide, we like it because it kind of, when you get actually live on the site itself, you can actually scan through the different phases in the product life cycle to kind of help you understand where you might fit for TI if you're looking to have an internship there. And you can actually click through and it'll tell you what an apps engineer does at TI, what a product engineer does at TI, what a technical sales engineer does at TI. And they are a driving force for us doing so well, so we're always looking for technical sales folks. And our design engineers. Every one of our design engineers that is working on something completely different. So if you want to learn more about what we do and where you might fit in, if you're looking for an internship, or if you're looking for a full-time opportunity, it's a place to go. In addition, I spend a lot of time here at MIT at all of the recruitment events that are going on campus. So we will be at the X Fair on Monday. We will have several different demos out there. So if you guys are planning on going, please stop by the TI booth and say hi to the team. I am part of the HR team, so I am not an engineer. So when I bring my entire team of engineers, it's so that you guys can really get into the nitty-gritty of the things that you really want to understand and know about our products and our type of work. Okay, so please come out and visit us. We're going to be there. I think the fair goes from 10 to 4, so we'll be there all day. We will also be selecting students during those conversations for interviews the following day. So it's a perfect opportunity for you if you're looking for something. Come and talk to us. We might find fit. Okay. That's really all I have. Okay.
So the career fair is on
Monday.
Monday.
Are you guys all familiar with the extra that's going on Monday? It's a big deal. So yeah, everybody knows.
Find the big red TI banner.
It's kind of like that.
And then these are the two different websites. So on the left side is the recruiting website. That's our students. It's our favorite because it has more information about the types of jobs and so forth. And then /university is my website. We also received a little card and a brochure about the competition. Yeah, I just want to reiterate that the utilization of this one board is what this workshop is about. It's a really cool board, but we have a lot of other devices. We gave you the brochure about the LaunchPad. So if you have a different need or perhaps a project that needs a slightly different chip or different configuration or more performance, and come and talk to me. We also support vivoboard.org, which is made with TI devices, and yeah, so come and talk to me about your particular project, try to get you about.
And we are currently recruiting a couple of design engineers and a lot of apps engineers. So if you have an interest in that, come see me. Now, there was a point that you wanted to make with spin over here, Kathy.
Oh, yes, of course. So that leads into it. Why does TI think that Kathy's job is important? Why did they let me go all around the world talking to students about our devices?
Feedback.
You
get instant feedback.
I get instant feedback and give feedback to the team. That's true. It's a strategic investment in. Another guess?
Your employees.
Employees for Adriana, that's true. What else? You using my CC3200, what might happen to you?
Might make a product based on it.
It's a strategic investment in our future. Our executives, and we've been running a program for over 30 years, our executives confirm that if you have a good experience with something while you're in university, the likelihood of you considering it later is not only possible, but actually does happen. So, where's Spin? Here's Spin. We hope that Spin will hire you, and you'll take CC3200 over to his company.
Hi, I'm Spin. I'm a master's student here at MIT, and over there on the board is our startup's name. It's called Tetra Science. We're actually making a company. It's like we call it the nest in the lab. We're trying to connect temperature sensors, humidity sensors, cameras, different kind of instruments, pumps, mass balancers, oscilloscopes, and all the kind of instruments that you can see in your lab to the same cloud platform using stuff that you have seen here, and also something like Vivophone that you have played around during the IAP course. So we use a lot of WebSocket, a lot of Node.js, a lot of Python, and we're hiring. So we just got our some money from the angel investors. Have started build a team, have a team about five or six people, and have customers in MIT, Harvard, and several pharmaceutical companies in Boston area. So we're ready to go, and we're hoping that you will consider our company as a choice for a summer internship or just as a part-time job during the semester. So my email is down there, spin1@mit.edu. So feel free to check out our website and email me if you're interested. Thanks for your time.
Thanks, Brian.
Thank you very much. So we got a couple of things coming up real quick. So some good news is that we've sort of worked through some of the wireless glitches and stuff like that we were having. So we should have a game of some sort. The TA trio is going to actually show what they've done to port the microcoap code to the CC3200, which is really very cool. And Kurt is going to give a couple of slides on the soldier design competition. So Kurt works over in one of the labs that's funded by some Defense Department initiative, and they have an annual soldier design competition. Have anybody heard of it before? It's Stewart does not count. Stewart's in the back, a West Point graduate who went to the Air Force and is in the graduate program here, but so that doesn't count. West Point actually has a track where the students have a course that focuses on the soldier design competition, and then they come up and they compete with MIT students, and they lose every year.
Whoa.
Oh, sorry.
Yeah, you can take a look at the trophy. I'm pretty sure West Point's on there more than MIT's.
Spin that down.
I'm
Okay.
just gonna toss that.
I just have two very important questions for Spin and for Infrared. Is Infrared still here? So the question is, Esther. The question is, Esther, is that how do you get email addresses that are like vanity license plates? So Esther's email address, not to disclose anything publicly, but isn't it like infrared at MIT.edu?
You just sign up for them when you become a student.
Oh, you can get like a vanity email. Does anybody else have anything other than like their birthright name?
Oh.
What's yours, Mark?
Well, I chose mine, but Bob finally had one I wanted to have.
Yeah.
So in 1970, I chose Bob F.
Wait till Bob F. Okay. Okay, so that's very creative. I think that's clever. It's good that you've got that choice. Choice is good. Okay, Kurt.
So I'll be quick, seeing that we're running an hour and a half behind. I run a bunch of contests. Part of my day job at the Institute for Soldier Nanotechnologies is to run a soldier design contest. And we reach out to every department. There's a lot of competitions, progressively more and more rapid prototyping competitions at MIT. We love Core 6 people. I talked to Mike Rodriguez, who had to take off, but he's probably going to repurpose his project into a soldier design competition. Which we get you together with some Army guys and pitch it. If it's not going the direction they want, which is military or first responder applications, they'll tell you, and then we can revisit it. But we're interested in the tech behind it. If you're an ARM programmer, a Linux programmer, an Arduino programmer, there may be a military spin for your design that you're going to do tonight. We did a couple of weeks ago. I also recruit for some of the other military-funded MIT competitions. Stuart can tell you about the International Ground Vehicle Competition. I don't think we've got an MIT team. There's about 20 universities that go to that.
50. It's actually international all across the world.
Okay.
You want to build on autonomous vehicles?
There's the Air Force Research Lab Challenge that's happening out at Natick in a couple of months. Natick Soldier Center, which is an Army Research Lab facility. I have no idea where all it is. The IPSO Alliance, you appreciate this, the Internet Protocol Standards Organization Alliance has a competition. Those you're working with here. Last year, it's only been around a couple of years. It differs kind of significantly from the TI Innovation Challenge. They want you to have IP, platform agnostic IP. And I can give you some details on that. The Cambridge, there's a lot of cyber stuff coming up. Cambridge College, Cambridge University, MIT, they're going to
put some information on the CISO website about that in a couple of weeks. So that's a cyber challenge between some number of students here and some numbers of students at the university. Capture the flag and the cyber challenge. The Air Force Institute of Technology runs a lot of these. They're almost always at Wright-Patterson Air Force Base. Here again, I don't think we've had an MIT team with the cyber challenge for a while. I think asking about those. RobotX is funded by the Navy equivalent of DARPA, which is the Office of Naval Research. A bunch of students and a bunch of faculty members spent a lot of time this summer putting together a boat on the Charles River that they've been shipped over to Marina Bay. Long story short, it won. The next RobotX thing won't be next year, but it'll almost certainly be in Cambridge, since MIT won it this year. You can ask Stuart about that too. And then, the various grant challenges. Office of the Secretary of Defense grant challenge for soldier wearable power. First prize was $1 million. These guys really know how to throw student competitions. The ref grant challenge. So the ref grant challenge, I think, is now the Service Academy, the DARPA Service Academy. And then finally, I also run the student cluster competition. So if you're a programmer, you know your way around. You don't have to be a C or a C++ programmer. If you know your way around a few codes, mostly taking a serial code and parallelizing it or moving it over to a GPU. So the good thing about this is we generally get funded to go to these conferences. They send an MIT team to the International Supercomputing Conference. We kind of won it one year because we have a team in each category, the standard track and the commodity track, which they've since gotten rid of. But we won the commodity track on a 96-node Panda board cluster in 2012. The Panda board cluster was unbelievable. You plug it's like you can do the Viva board now. Plug the USB in, get both power and USB net. You hit a command on your Linux box to send power to your USB port, and the Panda board cluster just crackled to life and got an address across USB net and then passed everything over to the Ethernet side of things. It was brilliant. Brian worked on it. We actually had a bunch of schools work on the Panda board cluster, and some of the students are represented, some Northeastern students. So if we want to do the next one, so we've already done the International Supercomputing Conference. The next one's the Asian Supercomputing Conference. So if you're a programmer of any variety, we have to send them 6 MIT names. If you don't have an MIT address, that's not going to stop us either. But we do have to put together, they've given us accounts on Tianhe 2, which is just the single fastest computer in the world. And it's in this university in Changsha. So ask me if you feel like you've got some free time in April. We have to pass this little exam online on the WiFi, and then we can put a team together. And this will probably be, the end of the line for us, because they may get rid of the student cluster competition and replace it with a SOC showcase. So that's a new set of criteria. It's more of a hardware competition than software. But ask me about any of these competitions, especially if you're a programmer. April should be fun. It only takes 30 hours to get to this place in China. You have to go through Beijing. So.
But is it non-stop to Beijing?
Pardon?
Is it non-stop to Beijing to Boston?
Oh, is it? Oh, that would be awesome.
And Bob's fine. Kurt, thank you very much for all. So these guys get set up. This is my chance to pitch my daughter, who is a soldier. So if anybody's interested in soldier design competition and you need someone you can drive a Humvee, I know just the gal. Okay, these guys have done some amazing stuff with getting this co-op and running and connected. We actually did, we got the networking issues worked out. There's something wild in this room where it's getting on lots of different subnets and I can't get things talking together. So one of the best investments that if you're doing any kind of testing in a startup or you're doing your own, sort of experimenting, is just your own wireless access point for $35 or so. This basically gives you something that will spit out dynamic IP addresses for your own local network, and then you can connect all your devices together on it. So it's kind of a nice way, at least on a local domain, to sort of have your devices connected. in a reliable fashion as well. So for 35 bucks, you know, you can't go wrong. I think. What's that?
Why just use a home one?
The home?
And people have these at home already.
If from like Verizon or from, well, then if I took this, well, my wife would be kicking me when I get home. Where's my Facebook?
Oh, we're playing outside.
Well, for instance, if we didn't have this tonight, I really wouldn't have a demo.
You could use the MIT one.
It's not functional for
Well, then it's broken.
It is, well, it
Then
is
fix
broken, which is.
Go to Starbucks.
Yeah, we can go to Starbucks. Actually, you know, and this is another, so people see the headline news that Marriott, was it Marriott? It was whacking people's Wi-Fi, they were shutting out your hotspots so that you couldn't use, you know, so people would go to a Marriott hotel and Marriott would make money from the hotels, but from the customers by, you know, 15 bucks a day or 30 bucks a day.
This is the mafia strategy.
This is the mafia strategy? Please elaborate.
You prevent people communicating and charge them for the cost.
Right. So they were actively upset because people with phones would be able to set up hotspots, which they could then, you know, permeate their rooms with, and then connect to their phones with their laptops, so they could bypass the Marriott billing system. So Marriott said, well, we'll just scramble the radio signals in any vicinity that, you know, that aren't ours. And somebody probably knows how to do that. Somebody probably doing that right tonight, in fact, and that may be my problem. But anyways, when discovered that, you know, people became rather upset that Marriott was actually doing this. So I think it was the FCC? So the FCC just in the past 48 hours came out and said, thou shalt never do that again. In very clear terms, which is kind of a good message in the sense of open and free access, which is that it's, you know, you just can't mess with people's radio waves, is what it is. So as this comes online, these guys, I kind of like the name, since I was the one who suggested it. Don't take offense at them for any, but anyways, looks like you guys are live, so take it away.
Hello everyone, my name is Georgios. I'm a graduate student at the Italian Canadian Computer Science Department. And I attended last week class, IoT class. It was a lot of fun. And during that class, we worked on a project building a device, of course using CC3200. And we build a device that can monitor temperature and moisture in your house and can alert you in case there is some leakage or in case the temperature of the exterior pipes goes below a threshold and there's danger of freezing. So we connected two sensors, one temperature and one moisture sensor to CC3200 port. We are reading these values and we are transmitting, we're creating a access point on the CC3200 and we're transmitting these measurements to a laptop and we're displaying these measurements over here. Making a connection to the presentations that we just had before, I'm using HTTP. I'm not using CoAP. So it is a lot more power consuming, more data transmitted. The protocol has more overhead and all the other details that were explained. This is the interface that we see the data. So yeah, it has two buttons and two indications about the moisture level and the temperature. If some water is detected, then the moisture level it becomes red and we detect a leakage. So we can either through our laptop or through our cell phone, we can press the button and we can actuate the pipe in order to close the main pipe. And right now we don't have connected CC32 hundreds with a electrified valve, but we have connected with the LED. So when I'm pressing this button, LED is turned on, and same for temperature. If I can activate another valve, and the other LED is going to turn on quickly, and I can close. So very quickly, within 1 or 2 days, me and other two team members, we built that system, and we used Energia. Now, making the connection to CoIP, here I'm using HTTP. So because of the power consumption involved with HTTP and the protocol overhead, we wanted to move to a more efficient protocol. And that's how we start searching for more efficient protocol. CoIP is a very nice candidate for this type of applications. And there are several implementations you can find a Java implementation, Go, and many other implementations. The three of us, the last week, we have been experimenting with different implementations. Right now, we are using an implementation called Micro Co-op. You can Google Micro Co-op, and you'll see GitHub. You can download the code, and you can, with a few modifications, you can directly compile on a CC3200 board, and you can do very cool stuff. Let me switch that. Let me connect to MIT Quest. Right now we have a micro CoIP implementation on the CC3200 board, and we are reading the accelerometer data, and we're transmitting. We're connecting to the MIT guest network, and we're connecting that data. We're communicating that data to our laptop. On the receiver side, you can have either command line interface, or you can use, as we use here, a plugin for Firefox. This plugin is called Copper. I can give more detail. We can help you setting up the system. It's fairly simple. And as you can see here, there are a few buttons. Discover. It discovers nearby devices. Then CoIP has 4 methods: get, post, put, and delete, as you can see over there. Right now we're going to get the accelerometer data from the board. And we can get, it is 60. I'm gonna flip the board the other way around, and now it should be negative, minus 60 or minus something, minus 64. So you can play around with the onboard sensors like the thermometer, the accelerometer, and other stuff, but you can also connect external sensors. You can read the data and very efficiently transmit them with the CoIP. If you press slide. Also, it is a two-way communication. You can set some values at the CC32, and then right now we're gonna turn off the red LED, and we're gonna do this by going to the outgoing tab, press 0, and then press put, and it is off. So it's fairly simple. I don't know, guys, if you want to add.
Yeah, it seems really simple now, but it took us maybe about a week to get this working. So, so there's a lot of work. There's a lot of I think for us there was a learning curve as well. So understanding what co-op is, how it works, how to compile it, how to use the tool properly, and I'm sure you guys have problems just understanding the different drivers and getting the different pieces working. So once we understood all the moving parts, then kind of integrating that was very easy. I think the Copper tool is pretty nice. If you have Firefox, I highly recommend just using that. There's also the option of running it from a command line from the unit shell script, so you can do that as well. Yep.
Could you explain the steps that you take for implementing that co-op?
Yeah, so we talked about that earlier. So what we can do is just write up just kind of a wiki or a Word document, email that out, or send it to the professor. We essentially download the code we showed you, put that into Energia, and essentially hit compile. There's a couple changes that you have to watch out for. We can point that out. So nothing terribly difficult after we figured it out. But that's pretty cool. Yeah, he's being quiet, but he did a lot of the work.
Actually, what was the memory footprint with Flash and RAM? I mean, it fit obviously the 3200. Did you have a lot?
Yeah, this is default settings of 3200. Yeah.
I don't remember the exact footprint on the memory, but compared to HTTP implementation, it's like an order of magnitude smaller, so something around that.
So easily fit, basically.
Yeah.
So what you mentioned that you used HTTP first and then you tried this. So what differences did you see in your application?
Well, right now I have the board connected to my laptop through USB, so I'm powering the board through USB. I don't see a big difference in terms of the lifetime, but if my board was connected, if it was powered by a source and it was at the basement of my house, then you would see difference in the lifetime. So using HTTP or some other more energy-consuming protocol, that would reduce lifetime. And of course, you won't be able to see that difference if you have connected your board to the wall. But if you do energy trace, I think the main difference would be energy savings.
So did you make any measurement to see how different you are?
No. I can point you another tool, the Code Composer Studio has energy trace capability. So through that tool, you can set up the tool to monitor the energy consumption. Brian can send you some links of that, and you can compare and quantify how much energy. But so far we have it.
And just to be clear on this too, I mean, this is totally cutting-edge stuff, right? I mean, how many people have actually implemented co-op in real live shipping products at this point in time? It's new. I mean, for a protocol to be a couple of years old is about what we're talking about, right? So it's kind of, so theoretically, given that it's a lighter weight, it's transmitting less data. All the theory is that, you're emitting fewer electrons into the atmosphere. It's going to take less energy. It's less transactions, and so therefore it should be lighter weight. But I did want to, in terms of powering it from my favorite color, actually pink, but not really. But given that there are at least some women and some pink batteries in the room. Anyways, I powered one of the CC3200s like overnight for less than 24 hours. Continually transmitting data every 10 seconds, and it burned through one of these batteries basically within 24 hours. Now, that was HTTP stuff, nothing was optimized. If you had one of these things that was out in the Arctic somewhere, atop a tree tracking jaguars or something like that, you'd want to make sure that you got every last bit out of it. And as Georgios was saying, TI's got some really cool stuff with this energy trace, where they've basically architected the chips so that it measures essentially every minuscule milliamp or microamp of what goes through the chip. And even the boards that you have right here, all those little headers that are on them, Mark can probably give you some guidance, but basically by popping those headers off, you can actually segregate off portions of the board, like for instance the sensors. And by doing that, you're no longer sending electricity through those parts of the board, and that would lower it as well. So the fact that you've actually constructed this in a way and you have that option, you could now meter it. By the way, these guys, well, not to point anyone out, were the first ones to grab the multimeter as well at the first week that we did this stuff. So we do have these, and for anybody who sticks around, we're more or less actually back on track at 8:30 for hackathon. Anybody who sticks around, we got at least some that we can share. You can pull your CC3200 out of your device after we do one more exercise, and then you can plug it into one of these, turn it on, and then it'll do the right thing. So, sorry. More questions?
Thank you.
Thanks very much. Okay, we should, you know, we kind of said 8:30, although we got off to a really wacky start. We'll after we, you know, people take a 10-minute bio break and just bail. I'll, you know, fire this thing up. We'll talk co-op. Bob Frankston will be hopefully around and talk a little bit more deeply. Mark, if, you know, people have questions about the boards. Any questions from what you've seen about how this works? One question actually that did come in was, hey, I'd love to, you know, learn more, maybe dig deeper. We talked about the big elephant in the room, which is security, which we really didn't delve into at all. If people wanted to follow up with this, I'm sure Kathy would love that opportunity to re-engage. But certainly security is one topic. You know, energy management is probably another topic, and then probably your dozens others. Questions?
So one of the things that Mark talked about a little bit that I know that we felt a little rush for time was the LaunchPad ecosystem and booster packs. If you're familiar with Arduino, they have shields. We have a similar family of community-driven add-ons, kind of like shields, we call them booster packs. But there's a little bit in the brochure. I just want to highlight that to you because if there's something that you're looking for to bring in to your system, one of the ones I wanted to highlight, but I'm leaving for Brian, is a new set from C Microsystems. There's a bunch of different sensors. They call them Grow, and it comes with the little booster pack that you put onto your LaunchPad. And I don't know how many are in here, 9 little sensors, and it's just a really cool kit. So if there's things like this that you're like, yeah, I'm going to build a project, Kathy, I'm really interested in getting my hands on one of those, that's what you can talk to me about. I'm very happy to take a little proposal and ship you a kit so that you can make your project even better even after we leave here today. Brian has some stuff here if we want to use during the...
Yeah, we've got buttons and buzzers and a variety of other things and wires and hookups and
The
stuff.
TI guys are here for the long haul.
Yeah. The beauty of it is you can now buy, you know, for $15, you could get a bucket full of sensors that would allow you to go out and do things that are, you know, the moisture sensor that they used was maybe 75 cents, right? So those came from IT Studio, which is somewhere in Shenzhen, China. And so, you know, it takes a couple weeks usually for them to deliver them, but they're readily accessible. And so, on the one hand, if you've got the electronic skills to, you know, wire up resistors and capacitors and semiconductors, you can do that and you can plug that right onto your boards. However, if you don't, but you understand that you need something that measures moisture or sound or light or, you know, all the senses, you can pick those sensors up really cheap. And all the sensors, like the Grove, for instance, and these IT Studio ones, really simple. There are 3 wires that you connect. One has power, one has ground, and the other has a signal. And the signal tends to, if it's like an analog thing, will give you the range of like the light intensity, for instance. Or if it's a digital thing like a button, whether or not the button is depressed. And so you just basically connect the power and the ground to your CC3200, and then you connect the signal pin to one of the pins on your board, and then you read that as an input or output. It's that simple. And then you fold it up in your, Kathy had one example that was, what was it, a frog or something like that? They did it at hackathon. And it is impressive with the accelerometer, the temperature sensor, and also you get a couple of buttons right on the board that you're off. What other questions? Can people see how they could use this kind of thing either in a personal project or a research project? Or the other thing is they're relatively inexpensive. So to get, they're very inexpensive given the processing capabilities that they have. So to get a network of these strung together, particularly with the wireless stuff, you know, you can do it on a really modest budget. One thing I didn't ask Chris, although I suspect that, you know, we've got some people in the room who talked to this, but generally, I think a lot of these startups are a couple of people. You know, they're not like $75 million VC funded, you know, startups, at least not on an early basis. They're kind of a couple of people with an itch to scratch, and that certainly is how the Nest folks got going. They just were, you know, hung up on the thermostat stuff. Questions? Hello. Okay, well, thanks for coming. 8:30, we'll be around. After a 5-minute break, I'll put up this game-like thing, and we'll keep at it. Are you gonna do something with these beautiful?
Yes, we're going to.
What do people have to do?
They need to make sure that they're on the spreadsheet.
Yeah, okay. Is everybody who's not signed in to share their social security number with Kathy? Is everybody signed in? Okay.
So then I'm gonna pull numbers.
You got full numbers, okay.
Or we can pass out numbers, that's fast.
How many of these t-shirts? Yes, how many of these? 15.
That's fine.
So I'd say between the t-shirts and the battery packs, people should walk out of here with something.
Yeah, I mean, we've got 19 t-shirts. There's probably something for everybody.
All right, so why don't we do an alternate? We'll do, you pick a number.
They can have any number they want.
Well, it'd be much better to have like a trade, you know.
Oh, trade on.
But they can barter.
All right.
So even numbers are t-shirts, odd numbers are battery packs. Books
Oh,
are,
the book is important.
books are wild cards. If you want a book, you just, right? If you want a book, you can pick it. Is that cool?
Sure. Off the spreadsheet or off the, so I don't know who's still here.
If they're not here, they're not gonna get it.
Okay.
It is. You got a bottle of Coke up there too. Let's get everything right on. Okay.
Okay, who's staying behind longer with us? That's important. Give a show of hands, who's gonna stay in that?
Is anybody gonna stay for you know, say half an hour, 45 minutes? Few people, half hour, 45 minutes? Okay. Everybody else can leave, we're not giving you anything. All right, so let's do this real quick, and then people can bail, and we can do a co-op deep dive, and, you know, I can get people to connect up with somebody.
Well, the fastest way to do it is to just make numbers and then we draw them.
Have you got the names on the spreadsheet?
Yeah, they don't have any. Hold on.
Okay, now the thing is, guys do not get picked. If you get a pink battery pack, just cup it out. Literally. But actually, they do have, they have.
Adriana, will you help me, please? Thank you so much. I feel like those pink batteries. How many people are in the room right
So
now?
my numbers are t-shirts, even numbers are batteries.
How many people are in the room?
I guess there are 32. But I think they're probably 28. We can count. That's an idea. It is an idea.
This is an idea that we should really handle that.
I was pretty close to 32.
Coming in all of them, I can start, it sounds really nice.
Oh, you said we can do it random.
We just have someone pick a number.
Well, you know, they're, you know.
Choose an accountant. Thank you everyone for your patience with getting this thing off the ground. I guess because we're killing time here, what would people do differently next time? Who's here that was on the wait list from the first event? Anybody? Who's here? Thank you for coming. Thank you. Big difference between a 4-hour thing and a 5-day thing, for sure, right? What people didn't get in this one that they got in the other one, there were a number of people who were in the other one, so it's a different experience, for sure.
You just had an oddest t-shirt.
Oddest t-shirt, even as batteries.
All right, pull a number out.
You got, 27, he's got an odd number.
Did you guys in the back row get your t-shirts?
Oh,
Girls, did you get your t-shirt?
And we're gonna do it in order of from 1 to 27.
Yeah, the earlier I don't,
Sorry, I just wanted.
the earlier at least you come down, the closer you're gonna get to your size on t-shirt, like these odd people.
We're doing them in numbers, sequentially. One, start with 1.
No, they have to join a number so that it's fair.
Yeah, right, I know, but you can start with low numbers. Otherwise, he's gonna take the whole grade off. Yeah, you gotta do some suspense.
Some
So keep going, keep going.
Alex. Who's got the camera? Ollie, you saw the camera? What else?
it.
You sold it?
It's on eBay.
Don't sell Chris's camera?
Can we get a 1 yet? Any ones? You started 1?
Imaginary numbers. This is MIT.
Part of the challenge. The challenge for doing this next time is somebody's gonna come up with a better plan than this. And you'll get a prize for it. Forget the TI Innovation Challenge, just come up with a better way to do this.
Oh, actually, can we take a group photo? Can we take a group photo? Yeah. No, we'll take a group photo. Yeah, after everybody gets a number, come on down, take a group photo. Kathy gets a bonus, so she comes out.
I get to buy better pizza.
We want that.
Better food.
Although I didn't finish the grades.
Do you want to put yours on track? Then you get a split. You don't want to be in the photo? That's what I'm in the photo? Okay, so then that's the timer.
Do we have numbers yet?
We're gonna, like here. Here, I'll get my camera. So we. Hope you guys are done.
Thanks for ordering the stuff for assessment. It was awesome. Mark, you can lower numbers up there. Anybody else not have a number?
Okay, number 1. Number 1? Any number 1s? Number 2? Where did number 1 go? Number 2, Gordon.
Come on down.
Number 2's a dad. He lives in there. Number 3? Number 3? Number 3? Where did number 3 go? Oh, Steven, come on down. Number 4. Laura, even is Gabby. Gabby,
And there's the colors.
the colors of the dots. Oh, 3. T-shirt. Pick a T-shirt. 4. Do we have 4 yet? 5? 5? Come on now. Come on. 5, 6. 5, 6, 7. 5, 6, 7. Odd is T-shirt, even is battery. And so just look at the dot. Look at the dot, and you get the color. You know, yeah, you want to grab a visual. 8, are we on 8 yet? 8, 9, 10. 8, 9, 10, Kurt, come on down. Ali, 8, 9, 10, come on now. 8, 9, 10, 11, 12, 13. 11, 12, 13. No, this is 13. 11, 12, 13, 14, 15, 16. Go on down. So, odd, T-shirt, even, or battery.
Yeah, temperature.
Oh, well, you gotta negotiate. Sure.
Not a lot, it's not like you run.
Right here?
We have 20, 21, 22? 21, 22? You must be close. 23, 24? 23, 24? Now, everybody signed in with Captain, right? Otherwise, okay. 23, 24, 25, 26, 27, 28, 29, 30. 29, 30, you figure out the color?
Which eyes?
You can trade if you want. Well, same
Putting them together on.
Yeah, this is better. We have Texas.
Yes. It's a cool color.
We got a lot. We got more.
Did you register your email in front of you?
Anybody 28 to 1,003 left in the room? Come on down and just, the t-shirt spot is a t-shirt and keep it in some Actually, these batteries, they're like 3 amp-hour batteries.
Stay for the photo. Stay for the photo.
I believe you.
It's a historical event. It's gonna get big.
Well, so basically the,
Does anyone not have a battery or a t-shirt?
I'm advertising.
James, you get.
So now it's going over as, or sorry. So in theory, I broke up.
Okay, let's take a quick picture. Where are we gonna line up? There's the, I mean, there's, why don't we just face stuff down? Yeah, there we go. We're gonna do good look.
I'm gonna put it in the mirror in the back. I gotta get my ad in.
Is the timer on? We're gonna lens switch over.
I think we're getting kind of third row, you're in a good place, is that right? Standing in the third row, standing in the fourth row.
Okay, hold on, I'm just gonna see which is better. And then make a.
He's a professional.
Make a
So
decision. Oh. This was the sample. Who needed a big one? It was where'd you go?
Very good place.
Oh, you have a big one?
Very excellent.
I know she didn't want to trade. What do you get? You get a t-shirt or a vest? I don't think we get anything. Oh, you didn't get a job. So she wants to pick Kathy. Kathy. Do you want the pink one? Do you want the pink one? It was a demonstration unit. It wasn't you. So you trade? What color did you get? Oh, yeah.
Alright. Everybody scrunch it. Scrunch it, I'm gonna make a picture.
There's a lot of money.
Everyone go and sleep.
A little more, guys, squeeze in like you like each other.
We have multiple rows. You're also in the dead center.
But do you also have the TI banner? You're not gonna be able to see the banner.
Oh,
Do
you
you want
can.
it on top of here so it's visible?
Oh, it's in the dead center.
Should we make it higher?
It's good.
Higher or lower down here?
Oh, that's wrong. Lower.
Lower? Maybe on the chair, maybe on the chair. On the chair? Yeah. Can you move it down?
Now it's
Too high?
you can still see it.
I think it was fun before.
Was it okay before? Was it okay before, Chris?
Yeah, it was fine.
Chris, do you want to put your camera on the table?
Go higher up, and you'll find more
Put your tripod on the table?
Oh, I can just increase the height possibly. I've never used this tripod.
No, maybe a tripod, but put the whole widget on the table.
It's fine, he's doing it.
Because I can see everyone.
Oh, okay, all right.
And the text instrument sign.
That's important, but there's gotta be like, Tom, you're in the back there. There's no way you can see Tom.
Whoever's right down this way though.
Tom's hiding,
Chops
maybe
like-
he's in the witness protection.
Chops like
Get in
this
here,
way?
guys.
We have so many free row space, including all this. It cuts off after Brian.
Joseph, come
That's
here.
not good for these guys. Get into more guys.
All right, ladies.
Where's limit here?
We're here. There's so much. There's so much space around you guys.
It's so much taller than you.
Yeah, that's true. Get everybody. All right, now I can see everyone. That's good. Let's see if this timer thing actually works. Otherwise, I'll just take it. I'm getting the picture. Okay.
How was the photo?
No flash. It looks good though.
Okay, good. All right.
Once I can get out of this.
So we're gonna take two. We're gonna take one serious one, and then like I tell all the little children in the classrooms, we'll take one silly one. Can you get out of it?
I can.
Good.
Okay.
Is this like an opportunity for IoT? Shouldn't you have a button back here or something?
I wish.
Motor control on it?
It's not flashing. It's not. There's no flash mode.
No. It flashes like for yellow.
It's a bug.
Chris, trust us. It should be flashing
Okay. Yellow.
Trust us. We saw it before.
I know what I was going to be doing a remote shoot.
We could put a Bluetooth on.
Yeah.
Hey, can we have an internet connected camera?
Yes.
Hello, we're trying to go to one wants to hire somebody who can program CC3200.
There you go.
Hey, Greg.
Uh-oh.
Ah.
A little bit. Hop over the table.
All right, let's see if it worked.
See the backward zip. Yes, it is.
Run straight to the tables and pop them.
Can I make it into this photo?
You are there.
Like, on track, just go for
I don't
it.
even remember what row I was just in. Oh, no, I didn't make it in. Let me.
Actually, come this way, right? From the other space.
There you go. Something like There you go. It's picture time.
It looked like something.
Great, well, if you want to run in front of me.
Just push it back again.
It's not that hard, James.
Hold it down.
Yeah. No, you gotta blink. It's gotta blink. Gotta blink. Everyone's giving me a hard time. You gotta really. Turns out.
I'm sorry about that.
What do you think of the speaker? What do you think of the speaker? So you can hear it.
Yeah, so basically.
Battery people, if you want to share.
Show your demo.
Okay, excuse me, guys.
Joe, show his demo. Announce your demo, Joe.
Yes.
Well, everyone very well with me.
Tell me what demo you have. Wi-Fi audio. We announced your demo. Okay, ladies and gentlemen, as you're packing up and leaving, come by and see Joe's Wi-Fi audio demo running on the board you've got. Wi-Fi audio running right here.
Thank you, everyone.
But now it's streaming. Yeah, I always wonder what people who listen to the on the phone when they get in the car. Sure, it's on radio, but
So did you just come?
listening to the streaming on the car. Well, look,
We're gonna do a demo.
So, you ready?
Sure. Right. But at the same time, everybody to have their own. Oh, is it yours?
Sorry, we're just so it's kind of done officially. Yeah, that's good. We're gonna do a little, thank you. Oh, yeah.
Okay, ready for my back.
Okay, I just want to take 3 minutes to show folks this. Can I borrow somebody's battery? Get a battery. Yeah, some of those batteries. Anybody got one? Any even people got a battery in them? Yeah, they're charged. I charge them. Okay, so witness this. So we're gonna take one of these batteries, right? And we're gonna plug it into the CC3200, which, if I'm lucky, will light up because it's already got the program. Once I hit a button here, right? So you hit the button on the battery pack. I should find it. Oh, there you go, I'm sorry, thanks, but thanks. Okay, so this thing's loaded up. The thing that everybody should know from what Mark did say, the programs, when you load them down onto this board, they stay there. It's not like they disappear when you take the power away, so they're basically flashed onto the board. So the beauty of that, you have power failure, this is a sensor of some sort, power comes back, the program loads in again, starts right up, and you're off and running, all right? So what this is doing right here is you can see that, so this is sending out some wireless signals to this dark server that I got running over there in the laptop. And what it's doing is, right here, let me just clear the screen a little bit. This is kind of a crazy screen. What is that? Oh, there it is. Okay. It's funny, I can't really see what I'm doing here, but so I won't bother. But basically, what it's doing is it's sending out signals. The name on this device is Wi-Fi Hack 1, right? The name on Stephen Ronan's device up in the back of the room is Stephen Ronan. So each one is spitting out a signal, and it's talking to the server, and as the server gets these requests coming in, it's just identifying them. So the game that I had put together was, everybody could put their name on it, and then as the names come in, it builds a map table of all the different players, and it kind of keeps score as people push the button on it. So when you push the button, it sends another signal. The signal then gets to this machine, adds up the total, then the person who hits the most buttons basically wins. There are a few kind of quirks to it in terms of how it worked, but that was the idea. So the interesting thing would really be to see if you can get more than just two of these devices fired up. So what I'll do is I will show you a URL. If you go to the URL and download the program that is there, you will then start to be received by this server machine.
So Brian, it's basically a one-bit Twitter.
It's a one-bit
Twitter. It's Twitter with one bit.
Yeah, that's a really nice way to put it. Yeah.
Bitter.
So it's the kind of thing where the design of it is you need some kind of a server to aggregate the data from these different endpoints in your sensor networks, right? So you need some way to aggregate that stuff. You potentially could do it on the CC3200. It gives you a basic web server model, but there's not much flexibility in terms of programming. So while I leave that server running, I'm just going to try and pull up a URL that you can connect. And for the first person who does this, I'll give them another board. So at least hopefully one person will do it. If not. Well, thank you. It was good to see you. For it, yeah. By the way, one of the things that Bob showed me was he's got these phones. You can buy phones on Amazon for like $45 now.
That's $30 on Microsoft.com.
He's got another one, $30 on Microsoft.com. What's it's Boost Mobile on Amazon.
Well, the Amazon is Boost, the Nokia one is Microsoft.
So if you're interested in developing these things and you need a device with a web interface, because most of your interactions with these devices will be through the web, right? So if you want a cheap, something cheaper than a tablet, just buy a cell phone with no
You buy prepaid and then don't pay.
Prepaid and don't pay, and then you've got a nice web browser interface to interact with these things as a control panel. Okay, so here is here's the application that's running on that CC3200, and it's really not. There's just one line in here that you can change, and it's where it says S. Ronan, which is Steve's name. Just put your name in there. So I'll show you where the. Let's see if I can get this to work. says this, I think it kind of went into battery depletion mode. I'll make that bigger. That's the URL that you need to go to. It's probably hard to type. Oops. Okay, so if you go to that short URL, goo.gl/capital O, capital U, capital E, 4, small y, and M, you'll find an Energia program. I don't quite know what to call these things because somebody asked what language is it, which is a great question. Actually, I asked the question of Robert today. Is it more C or C++? Mark described it nicely as kind of a bit of a hybrid. But Energia is the IDE, the developer environment, similar to the Arduino IDE, and essentially it's a port of that. But if you go to this URL, Google OUE4YM, and just copy that whole program into Energia, and then you make a change replacing Stevens S. Ronan with your vanity name of choice, you'll then see it appear on
Destination server.
What's that?
Destination server.
You don't have to change that. That's all.
That's blank string right now.
What's that?
That's a blank string in the code that's up there.
Oh, it is?
Yeah.
Sorry, thanks for pointing that out.
Show the URL again.
This is it might be a different, this is ugly code. So but you'll see destination server 192.168.3.100. Everybody see that? It shouldn't be blank.
Can you show again the URL, right?
Say that again?
Can you show the URL again?
Oh yeah, sorry, yeah. Good point. There were probably a couple of gists. These things. And so it's the other one that was blank. Thanks for pointing that out. And then so my take is that if you can take example applications, modify them slightly, make them your own, and then use them, and then customize them and tailor them to your needs, that's, at least for me, a really good way to learn this stuff. And I, somewhat purposely left in all sorts of junk in there. So you'll see how you have to go through and debug these things and print stuff out, and, and then just start with a blank slate later on. But
so besides your name, what else to change?
all you got to do is change your name.
Yes.
And then save it and download it to your board. See if anybody actually stuck in there. So you see Steven's name still popping up. You see Wi-Fi hack. Who's Y-tongue? Well done. You get what do you get? A handshake. No. Okay, so you see his. It just scrolled off this. I didn't see it. Did anybody see it? It scrolled off this. No. Actually, so Nick. I see Nick's name. Esther. It only counts if you're influenced. Sorry. Kahan. Okay, so you see these things. People are kind of getting it now, right? So let me explain briefly what this is doing, and then I think it's a model that you can use, whether it's to keep track of where your bicycle is or your, or your keys are. So what that program is doing basically is every 10 seconds, it's just sending out a ping to the server that it's connected to, okay? And every 10 seconds, and this is setting up, so it's got some different descriptors on it, but basically it's sending a periodic message out into the ether, and everybody's server that's out there in the ether could be listening to this, right? And if it's not encrypted, which it isn't, if it's not, then everybody could be reading this, whether it is your social security number, or your credit card information, or how much water you pump through your sprinklers. So then with this, what you can do, the beauty of Dart, in my experience, is that it's really easy to parse through this data in real time and extract out the data basically that's been bundled along with these messages. The data might be the accelerometer coordinates, or it might be some clever algorithm that you have concocted to measure the moisture in your garden, right? And then what we didn't go there, but you easily could with the same platform with the Dart server, you could have a browser come in, hit that same server, and extract the information in a more attractive way, rather than just having it scrolling across the screen. So I see Georgios' name there. You see a couple different things. This is part of a sample program that I did with something that responds to magnets, so like if it opens a door, it would activate. Also a passive infrared, so if you've got a cat walks by, you want to know that's when they're using the exit door, and a few other mechanical things like buttons as well. But really the only purpose of this was to show you how easy it is to grab something, connect it wirelessly. Now, all of the problem that I had earlier, and I don't have an explanation for it, is every time I connect, and I suspect it's true for all of you, every time you connected that CC3200 to the MITS network, it was giving that device an IP address under this dynamic host program protocol stuff, right? But those IP addresses that I was getting were in different subnets. Then they weren't in the same subnet, which typically is the way this stuff works, right? And it's difficult to ship packets between subnets for a whole host of different reasons. So in that program, if you go back and see, what you're actually doing is the SSID that you're looking for is IoT1, which is emanating from this little box here. So your CC3200s are talking to these antennas, and this laptop, aka your server, is also connected to this antenna. Now, if the way the server is set up is that if the threshold is met for a certain level of alert, like it's not just moisture in the basement, but it's a flood, then it could send out an email or a text message or set off some other kind of alarm system, which is what my interest is. But to do that, you either need like a GSM card, or you need access to the cloud, to the internet, and so there you have it. Any questions on? It's probably I don't know how many lines of code it is. You can count because it just has it. But of the 200 lines of code that are there probably are only like 32 that are really useful, and the other stuff you can just cleanse away.
You got the client code, right? And that's different from your server code?
It is.
Okay.
So I would be happy to share the server code, which is written in Dart, which can run on a Mac, a Windows machine, or a Linux box. I would be happy to share a game server with anyone who is interested. And the reason it runs on, like a bigger box, is because if you want to do parsing, if you want to send out emails or text messages, can't do that on the 3200, as brilliant as it is, right? I mean, I guess you could if you connect to a third-party service. There are a lot of different ways to do it, but personally, I like to keep the stuff in mind. So my model of how this stuff works is you've got a bunch of sensor devices, kind of relatively inexpensive, reliable. The beauty of the CC3200 is that it meets all those criteria, and it is powerful as well, right? And I think, the guys in the back who worked on that demo, we got some real good help from Robert, who's the guy that's, works alongside Kathy and is like the architect of the energy and stuff. He was helpful with the micro co-op, and, my next question to him is, what about security? You know, how about encryption? Okay, so we got this micro co-op stuff working. These guys, you know, Kathy's got video and it's gonna show up on the TI.com website. Now what we want to do is we want to encrypt that, you know, those droplets of data. How do we do that? And so somebody mentioned, Mark, I think that maybe it's not in the firmware or maybe it's not. So one of the things you'll see on all your boards is a little connector. It might be white or yellow or you know, blue or a green or a jumper. So I went through all the boards and I did two things to them. One is I updated the firmware. So the firmware is like the operating system for these small board computers, right? It's just the thing that wires it all together. The beauty of firmware is that you can update it more easily than you can update the hardware. And TI seems to really have their act together on this stuff. So for all the boards, I had to, you know, sort of blast onto it a more recent version of the firmware, which is kind of required for the Wi-Fi to work properly. Okay. And then there's another modification that the thing that you see connected there is a way to bypass basically every time you download a program from Energia, it's actually copying that binary program onto the board. And to do that, the board basically has to say, okay, it's okay to write on me. Currently, the way they have that, basically the way they do it is you have to shut the thing down, pop a header off, you know, do the write, and then shut the board down and do the, anyways, they came up with a clever way to jumper that situation. That's why you've got the cable on it. To actually upload to update the firmware takes 30 seconds. It's really a no-brainer. It comes with the service pack kind of update thing. You know, our nightmare experience is updating the operating systems that we commonly work with, which might take, you know, many minutes, if not, you know, longer. These things are typically a snap. The one downside right now is that it does require a Windows machine to the firmware update code is written in Code Composer, which is, you know, essentially TI's higher end, more sophisticated code development environment. Anyways, it works on Windows, does not work on Linux, does not work on Macintosh currently. The design that they had in mind would be the same way you download a program to the board, you'd also be able to download the firmware to the board. Joe, I don't think I'm making this stuff up, or Mark.
No, well, there's a Uniflash actually that does it. That's what I do. There's a Uniflash, which is a Windows-based only, so that's why.
Which is Windows only.
Right, so everything Windows-based.
Which I think is a Code Composer application.
Right, yeah, it's like a separate.
Right. So Uniflash is the thing. So anyways, you know, get a friend who has but this is it's like December or something that the firmware was coming up.
Quick question on you said the server is a Linux box. Do you think the server would actually run on the 3200 of your demo here?
Yeah,
it has the horsepower?
Yeah, these guys did. One of the things that I haven't personally done, but they can talk about it. Those boards can be set up as access points in access point mode. One of the beauty of the chips is that it supports station mode, which is like as a client, right? So it gets an IP address. But also it supports AP mode, access point mode, also Wi-Fi direct, which is kind of peer-to-peer stuff. And you guys actually set it up as a server, right?
Yeah. So it'd be interesting that's good to know.
And it works well, and it works well for simple things. When it gets to, though, for instance, if you want to do data aggregation, or if you want to parse, the way I did the game-like thing is basically just parses the URL that comes in as the request, grabs the section out that's the person's name, stuffs it into essentially a table, and then accumulates the hits from that person. To do that in the Energia environment, you probably could, but it would take a while. Any questions? You've been great to hang out. Any co-op questions? Is there anybody who would be interested in working on the co-op stuff, the protocol stuff? The bill of security, with it as well? So if you're interested, and I see some hands, personally, I think that it's a significant industry event to get the co-op stuff running on the CC3200. My understanding with the TI folks is that they typically don't even demo Wi-Fi in some of the university demonstrations because it's oftentimes problematic to get access. MIT's got the open network. Is that true, Mark?
That's right. Yeah, the security's tight.
Yeah, so the fact that everybody here connected wirelessly and in multiple different variations is significant. But to push it further and to say that the co-op stuff works is really cool. So, and so I'll send some follow-up out. This guy Zach Selby, who was the one who did he seemed to be the one who spearheaded the co-op effort and the original spec. He was with Sensinode. Does anybody know anything about that company? You didn't work there, did you? Sensinode? I think the guy Toby who did the micro co-op code may have worked with Zach at some point. Anyways, he sent me a bunch of his favorite, discussions and reflections on the evolution. Only a couple years old. So we will, let's say we'll follow up on co-op, we'll follow up on security, and if anybody has application requests or needs or projects, send a proposal to Kathy. She'll be on the email list, and she has been very supportive of all that's going on leading to this point. Anything else? Otherwise, feel free to hang out. We've got the room until 10 o'clock. I don't think anybody's going to kick us out. Thank you very much. I did say that I gave you another 60. He was the first one. He was the first one. Yeah. He was the first one. Not that I know. I mean, like Stuart, Stuart, what was the name of the group that you did? You had like a lab, or you had a computer group, or the question from Nick was, do these meetings ever take place any other time during the year? Well, this type of thing. But what did you do? Oh yeah, you can just reserve a room. You had like a club, basically, right? What did you call it now? Was it like an electronic?
West Point is there's here, we've got a couple different groups, stuff like this. In CSIL, there's the CSIL room calendar. Anybody with credentials can access that room. Each of the buildings is a little bit different. It's run by different departments, but most departments have a central place where you can reserve rooms.
So Stuart, if people want, by the way, Stuart is the guy who, he came up with the insight for just, set up a separate standalone access. Thanks for that. Otherwise, I'd have been no demo. But so who would be the one, Stuart? You, Georgios, Nick? I mean, anybody here who would be willing to set something up that just, spontaneously on a Friday night, and then we twist Kathy's arm for pizza?
Yeah, sure. So it's like I've access to CSIL calendar, so I can do stuff in there. The library is also a good place to set up stuff. They have large areas, what you're trying to do. EECS and CSIL are a little bit better because most of their rooms are just rigged with outlets because they like outlets. But you can do it in almost any building on campus if you can just ask for your.
No, but you're talking about room reservations. I'm talking about, are there any existing groups that organize?
Oh,
these
sorry.
kinds of events?
There's a lot of informal groups that do different things, but most of them are like a handful of people. There isn't like a centralized hacker club for the geek side of things. For the mechanical side of things, there's a couple different student clubs, and they do a little bit of electronics. But everybody in the East does their own hacking like this of some kind. So if there's something specific you're looking for, you can find that. If there isn't necessarily just a general club.
Okay. The thing that, like Chris's group, very large group, most of the folks are, my impression, business oriented. And so in terms of people who really want to get in and do the development, hands-on kinds of stuff, I mean, I guess that they're there, but his group doesn't focus on that. So,
yeah, part of the reasons why it's a lot of little groups is everybody's very entrepreneurial, which is great. That also means everybody kind of breaks off and does their own little thing, and they don't interact as much. You can get on CSIL related, which is kind of a generic email broadcast for CSIL, and just get on there and say, hey, I've got this project and I'm interested in doing this. Is anybody else interested? And I can almost guarantee you'll get at least one person to apply. Because there's all sorts of stuff.
Right, yeah, let me see your server, I'm just checking the program, to see if that's come up. Oh, yeah, they disappeared.
That's the big issue, is maker spaces are, yeah, which is funny speaking. I don't see how a lot of experiences. I grew up, right? I've been doing I can take a look at skills.
Does it, is there a wider
Yeah, there's a student panel. And I'm a. And I will have to monitor these I'm glad that we're here. At the end of the day, the hot. No, but I have access to the
Hey, Steve, thanks so much. Yeah, so basically, you guys are doing.
It's like these one other people actually have you. Awesome. Yeah, you say that.
And this one, so this guy, no, it's very helpful. Really new.
It's great to see the marketing.
Yes, this is the first product.
Marketing.
These guys have pretty good nice things, but they also are like it's not super.
No, but I think
it was like. I'll send you.
No.